after great struggle and hard work, has achieved great recognition in India, both in academic circles as well as industrial circles. However, the Institute is in no complacent mood with its achievements and continues to strive hard to reach greater heights and recognitions not only in India but also globally by updating its teaching facilities and laboratories.
In India, standards are improving, standards are going up, and they're looking for people from India to employ.
నేను విజయనగరంలో చదువుకునేవాడిని ఇంజనీరింగ్. వెళ్ళడానికి గంట, రావడానికి గంట. బస్సు ప్రయాణం, కాలేజ్ బస్సు, మహారాజా కాలేజ్.
GRC, after great struggle and hard work, has achieved great recognition in India, both in academic circles as well as industrial circles. However, the Institute is in no complacent mood with its achievements and continues
Hi, good evening all.
Good evening, sir.
Yeah, good evening. Am I audible? Good
Yeah,
evening,
audible, sir. Just 2 more minutes.
Yeah, no problem.
1 minute, sir. Just HOD is also going to join now.
Sir, good evening, sir. Anil Kumar, sir.
Very good evening, sir.
Am I audible, Subramanian, sir?
Yes, sir. Audible, sir, now. We'll start.
Okay, sir, you can proceed, sir.
Yeah. Thank you, sir. Good evening, everyone. It gives me immense pleasure to welcome you all to the inaugural session of the AST Training and Learning ATAL Academy, sponsored 6-day online faculty development program on innovative green energy generation and storage technologies. On behalf of MVZR College of Engineering, I extend my warm greetings to today's chief guest, Professor Anil Kumar, Professor of Mechanical Engineering, Dean Sponsored Research and Consultancy from IIT Tirupati. Esteemed speakers, Honorable Director, Principal, HOD, and distinguished faculty members, and all the participants who have joined us today. As we know, in today's world, energy is at the core of global sustainability challenges as we try to transition to cleaner, greener, and more efficient energy systems. The role of innovation in energy generation and storage becomes critical. This FDP has been meticulously designed to bring together researchers, academicians, and industry professionals to explore advancements and innovations in green energy generation and storage technologies, which is a topic of utmost importance in our pursuit of sustainable development and energy security. The main objective of this faculty development program is to provide the participants with comprehensive knowledge of innovative green energy generation and advanced storage technologies, and also to enhance the skills of researchers and faculty in designing and implementing cutting-edge renewable energy solutions, and also to bridge the gap between industry requirements and academic expertise by fostering innovation in the renewable energy sector. We are honored to have with us eminent experts from academia, industry, and research organizations whose insights and expertise will undoubtedly enrich this program. Their valuable contributions will provide us with a deeper understanding of the latest trends, challenges, and opportunities in the field of green energy generation and storage technologies. I'm truly delighted to see such a strong and enthusiastic participation from over 200 faculty members, along with research scholars, PG students, and industry professionals who have registered for this FDP program from various institutions across the country. This overwhelming response speaks volumes about the growing interest and commitment to sustainable energy solutions and their integration into academia. Further, the diversity in our participants will bring a rich blend of perspectives and experiences, and we are confident that it will contribute to a fruitful exchange of knowledge and ideas throughout this program. Let us make this faculty development program a platform for learning, collaboration, and exchange of ideas. I encourage all participants to engage actively, ask questions, and network with the speakers to maximize the benefit of the program. I also take this opportunity to thank AICTE ATAL Academy for their unwavering support and for providing this platform that fosters the professional development of faculty members, research scholars, professionals from industries across the nation. And also my special thanks to our respected management and faculty for their steady encouragement in driving such initiatives. Once again, a very warm welcome to all of you, and we look forward to an engaging and enriching weekend. Thank you. And I now invite the head of the Department of Mechanical Engineering to address the gathering. Thank you. Over to Professor Ravikumar Garu.
Thank you, Subramanian Garu. So I welcome, heartily welcome for the today chief guest, Dr. Anil Kumar Garu, and all the participants who joined this FDP program. And from the Department of Mechanical Engineering, very welcome all of you for this ATAL FDP program. And recently, we also conducted previously several online FDP programs. So we get very good response from all the participants, especially on hybrid electric vehicles. Maybe some of you are already participated in our earlier workshop series. So we have received a very good feedback based on what are the content we provided from different spokespersons from community, from industry, as well as from institutions across different institutions. We brought experts from different diversified fields, and we can bring together and we can able to provide that content to all our participants. And this time also, our coordinator, Dr. Subramaniam, and his colleagues done very meticulous effort to put very excellent speakers in this program. And you may definitely get benefited from this program for your research and as well as for your career. And especially whenever it comes to the Department of Mechanical Engineering in MVGR, so we have very strong community of faculty here with 28 number in C. Among 28 faculty members, so we have 21 members are PhD holders. So that is a very good number where we have very strong community of research faculty will be there with the diversified who are from different IITs, NITs, and other university people will be there. And the research areas also diversified in across from materials, CFD, even renewable energy technologies, material characterization, even design, everything. So we have very strong community will be there. So participants, if you are interested in any research field further for any joint proposals, anything, we are welcome to go further in this direction also. So you can able to go through our website, probably you can able to see our faculty profiles also, you can able to meet together. And coming to this main theme of the hydrogen energy production and sustainable energy storage technologies, innovative green energy and generation and storage technologies. So normally we all know that how the government is also taking care of this sustainable energy is a main important theme. So if you see last year, I think in January 2023, I think, so India, government of India also launched one national renewable energy mission, green energy mission. So with some target of around 5 million metric tons of production of green hydrogen. And at the same time, we can see some sustainable energy technologies like even solar energy, how government of India will take a bold step to make a national rooftop solar mission for every household who can able to produce some solar energy. And Government of India also very ambitious to generate almost 500 gigawatts of solar energy, renewable energy by 2030 actually. So it is a very promising state. Probably we are also having different denitrogen energy production technologies in our hand. So there are so many technologies already in practice. So people are doing so many research methods to harness this green hydrogen. But they have each and every method have its own advantages and limitations will be there. And at the same time, facilities normally require some little bit more costly process may be incurred sometimes. So probably whenever we can combine together, we can able to work and we can able to do much more research in this area, and we can able to develop some sustainable systems for this thing. I once again welcome to all the participants for this program. I hope you will be enriched with good knowledge, and you will be benefited more by help of this series of this week and lectures from expert speakers, and you will able to get a good idea about this particular hydrogen generation as well as storage technologies. I wish you all the best. Thank you. Thank you for giving me this opportunity.
Thank you, Professor Ravikumar Garu, for your inspiring and thought-provoking address. Your insights have set the tone for this faculty development program and emphasized the importance of green energy generation and storage technologies. It is my privilege to invite our esteemed chief guest, Professor Anil Kumar, Department of Mechanical Engineering and Dean Sponsored Research and Consultancy at IIT Tirupati, to address the gathering. Professor Anil Kumar has made remarkable contribution to the field of engineering and innovation, particularly in hydrogen storage technologies. We are truly honored to have him with us today to share his expertise and insights. Before we invite our chief guest, Professor Anil Kumar, to address us, I would like to request Dr. K. Ravikumar, co-coordinator of this FDP, to kindly present his profile. Over to Dr. K. Ravikumar.
Thank you, sir. Good evening to everyone present here. It is my privilege and honor to introduce an eminent academician and distinguished researcher, Dr. E. Anil Kumar, sir, who has made significant contributions to the field of mechanical engineering. Dr. Anil Kumar, sir, is currently serving as a professor in the Department of Mechanical Engineering and Dean of Sponsored Research and Consultancy at IIT Tirupati, a role that underscoring his commitment to the both academia and industry-driven innovation. Dr. Anil Kumar sir holds his PhD from the prestigious institute IIT Madras, where he laid the foundation for his remarkable academic career. He later held esteemed position as assistant professor and associate professor at IIT Indore, where he also served as associate dean of academic affairs. His visionary leadership is exemplified by his pivotal role as a founding head of the mechanical engineering departments at IIT Indore and IIT Tirupati. With the deep passion for the research, Dr. Anil Kumar sir expertise spanned critical areas such as thermodynamic and thermophysical properties of solid-state hydrogen storage materials, thermal energy storage, carbon dioxide capture, and sorption heating and cooling systems. He has authored over 100 research papers published in reputed international journals and conference proceedings, making substantial contribution to the global knowledge pool. His excellence in the research is further reflected in the successful execution of 8 sponsored research projects worth over 3 crores, with more promising projects in the pipeline. Dr. Dr. Anil Kumar sir influences extends beyond research and teaching. He is an editorial board member of Wiley Journal, Energy Storage, and review committee member for the Technology Missions Division of the Department of Science and Technology, India. His service as a reviewer for over 200 journal articles from renowned publishers such as Elsewhere, Springer, Wiley, Taylor and Francis demonstrates his dedication to maintaining the highest standards in the scientific research. Furthermore, he serves as a member of Board of Studies and Board of Research for several autonomous engineering institutions, shaping the academic landscape for future generations. His contributions continues to inspire students, researchers, and fellow academicians alike. Let us all extend a heartfelt welcome to Dr. E. Anil Kumar sir, whose expertise and insights will be undoubtedly enrich our learning and experience today inaugural session. Thank you, sir.
Thank you, Dr. Ravi. First of all, I would like to thank the management of MVGR, the organizers of this program, Dr. Subramaniam, Dr. Ravi Kumar, and for inviting me to share some of my thoughts during this inaugurational session. I'm greatly honored to be here to share some of my thoughts. I would like to appreciate the organizers for choosing such a contemporary topic of harnessing green energy and storing, as that is the need of the hour to move towards carbon neutrality. So if you see energy as an entity, that energy exists everywhere all the time, even before the human race started. And we used different forms of energy, but the actual acceleration of energy conversion from one form of the energy to another form started after greater inventions in mechanical engineering, especially steam engine, which has mechanized the processes earlier which were done manually into a mechanical process. So later, following the steam engine, many engines were invented to convert basically the thermal energy into mechanical energy, like petrol engine, diesel engine, turbines, gas turbines, steam turbines, etc. So all these inventions has facilitated the conversion of thermal energy into mechanical energy, thereby into electrical energy. So while doing it so, we largely dependent on the fossil fuels, okay, which have been taken millions of years to form. And if you see for the last 250 years, the rate at which we are taking out these fossil fuels and burning them and using has rapidly increased, and it is still further increasing. But at one point of time, we have realized that it is causing environmental damage by producing more carbon dioxide and carbon monoxide. By releasing them into environment, we are leading to global emissions, global warming, thereby it is a threat to the earth itself. And then the thinking process started how to reduce the amount of utilization of these fossil fuels. But it has been established for hundreds of years, maybe more than 200 years. All of a sudden, we cannot change. Okay. So if you see, especially with respect to the tropical countries like India, we have a lot of solar and a lot of seashore also. Seashore has a lot of wind energy. So solar energy and wind energy, there is a lot of potential for solar and wind. And not only that, any country's economy mainly depends upon the quality of the energy that the country can afford for manufacturing and transportation and other sectors. So if you see with respect to Indian context, we majorly dependent on imports for especially our transportation requirements, because we use majorly petrol, diesel, natural gas, and all these fuels we import. So most of our foreign exchange goes there, paying bills for importing these fuels. So being a tropical country where large amount of resources are available for harnessing solar and wind energy, we should be able to reduce our dependency on fossil fuels for our day-to-day energy requirements. Maybe it is for industries or cooking or transportation, all these applications. So when it comes to the major form of energy that is widely used is electrical energy. So the electrical energy is produced at present. If you see, India is capable of producing nearly 450,000 megawatts of energy. And in the last 10 years, there is a major transition from fossil fuel based energies to renewable energies. But the challenges still lie there because all the electrical energy requirements of the country are connected by a grid. So there, the supply of electrical energy to the grid should be equal to the energy at which it is being utilized. Otherwise, it disrupts the grid balance. It will lead to the grid failure also. So when we want to move more towards solar and wind energies, the major challenge is how we integrate these highly intermittent energy sources with the end usage requirements. Maybe it is electrical energy or transportation requirements or cooking requirements, industrial requirements, whatever it may be. So the major challenge lies how we can integrate these renewable energy sources with the end users. Especially if you take grid, we require major energy storage requirements. Okay, because we know that solar energy is intermittent in a day and it also varies with the season. If you take in a day, we have good solar insolation for a few hours, and nighttime we won't get any solar energy. Similarly, wind also it has a trend, but it is not 100% predictable, the amount of wind energy we can harness. Okay, so to have a stable supply and demand, we should be able to develop larger energy storage systems. So if you look around, what are the different ways we can store energy? Electrical energy, especially, we end up with seeing at batteries. Batteries, yes, they are good. Their efficiency is increasing. The energy storage capability is increasing, but the batteries may not be suitable for storing at grid level. Few gigawatts of energy, because we require few stories of multi-stored battery systems, which are not practically feasible to maintain. Okay, so there may be different applications, different ways of storing energy, like pumped hydro. We have two reservoirs at two different elevations. When you have excess solar, excess wind, you can pump water from a lower reservoir to a higher reservoir. And when you have insufficient energy harness, then you can reverse by using a turbine. So that is one method. Especially even in Andhra, a pilot plant is coming near Kadapa Kurnool region, where the demonstration is taking place with the solar PV as well as this pumped hydro between two reservoirs with the elevation. That may not be possible at all the locations. Okay, so compressed air, that is one way of storing energy. Okay, so there are multiple ways. So there, hydrogen is coming up as a very alternative and flexible energy storage kind of system for the future. Especially when you have more excess solar and excess wind, you can generate hydrogen, green hydrogen, using electrolysis process. This green hydrogen can be used as a fuel or even for ammonia production, where again, the fertilizers is one more costly bill for us. We import a lot of fertilizers. If we can make our own ammonia using green hydrogen, green ammonia, we can reduce the fertilizer import from other countries. Okay, so there the government also realized the importance of green hydrogen. They have come up with the Indian Hydrogen Energy Mission. So nearly 20,000 crores being invested in the next few years to develop green hydrogen based systems. But similarly, we have solar energy policy, we have wind energy policy. So even all these things are there, but still a lot of research is required to take these things to a grid level or a major applications, to take these into where we can combine these intermittent energy sources to the major energy requirements of the country. So we should be able to increase the solar efficiency, PV cell efficiencies or solar thermal efficiency. We should be able to increase the structural stability of the windmills, thereby harnessing more wind energy and stable wind energy. And we should be able to integrate these renewables effectively with the end users, especially for grid and other industrial applications. Okay, so in my opinion, the workshops or seminars like this, where I have seen the contents or the speakers of the workshop. There are eminent speakers from national important institutions or industries, R&Ds. So everyone has expertise in certain field. So when they share their knowledge, their ideas, okay, it is beneficial for all of us to learn from each other and work towards improving the efficiencies of these renewable energy systems or developing highly efficient energy storage systems. Okay, so I wish all the best for the organizers. Looking forward to learn from this workshop, and I wish all the best for all the participants. Okay, you please use this opportunity to learn from the experts, to make networks, make connections, and keep working in this very important area to contribute to the nation's growth. Thank you very much.
Thank you, sir. So, thank you for your valuable insights towards this green energy technologies. So, I would like to begin by expressing my sincere gratitude to our chief guest, Dr. E. Anil Kumar Garu, for graciously joining us today. His extensive expertise in green energy technology, particularly hydrogen storage and advancements in thermal storage systems, promising to inspire and enrich us throughout this program. As Dr. Anil Kumar Garu aptly mentioned, we are living in an era where sustainability is no longer as a choice but necessity. The pressing need to transition to renewable energy and adopt advanced storage solutions is essential to addressing the global energy crisis, mitigating climate change, and fostering a greener and more sustainable planet. In alignment with these global imperatives, this FDP has been meticulously designed to equip participants with in-depth knowledge of advanced technologies such as solar innovations, hydrogen production, smart grids, and integration of AI/ML in energy systems. This initiative reflects our ongoing commitment to advancing cutting-edge research and solutions. At Avniger College of Engineering, we have always been at forefront of academic excellence and research. Our well-established mechanical engineering department, recognized as research center by Day1 Vijayanagaram. So this commitment to excel is made possible by the supporting and leadership from our esteemed patrons, who guide us in our continuous pursuit of academic and research advancements. I would like to extend my sincere appreciation to everyone who was a backbone for this FDP program. So without their valuable contributions and suggestions, the successful initiation of this program would not have been possible. The focus of this FDP on cutting-edge topics like solar energy innovations, hydrogen production and storage, AI/ML in energy systems, smart grids, and advanced battery technologies is not only timely but essential. As world faces growing energy challenges, the role of academia in finding sustainable solution is more important than ever. To our participants, faculty members, researchers, and industry professionals, I encourage you to actively engage with the expert speakers who bring a wealth of knowledge from esteemed institutions and industries worldwide. This is a unique opportunity to explore new frontiers in renewable energy and storage technology and to bridge the gap between the academic research and industry needs. Once again, I extend my warmest thanks to Dr. Anil Kumar Garu for gracing this occasion and sharing his valuable insights. I am confident that the discussion over the next 6 days will be enriching, inspiring, and impactful. Let us work together to the advanced cause of sustainable energy and contribute to a greener future. Finally, I would like to say the future of energy lies in innovation, sustainability, and collaboration. Thank you, and I wish you all a successful and productive FDP. Thank you so much, sir. Thank you, Anil Kumar Garu, for gracing this occasion, sir.
Yeah, thank you. Thank you. All the best
Thank you,
for
sir.
the organizers and
Thank you very much.
participants. Okay. Shall I sign off?
Yes, sir. Sure, sir.
Yeah, thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir. Okay, dear participants, so upcoming sessions will be followed by Dr. Jinsa. He is going to take the session. So it will be starting within 1 minute.
The participants may use the chat session to ask any questions to the speaker. Probably we can enable the chat once the speaker will complete the lecture. So the chat will be enabled. The participants may ask the questions. So the questions will be answered by the speaker at the end of the session.
Yes, sir. Only so chat will be enabled during the only question and answers session only.
Yes, sir.
After the completion of the session.
Sorry, join, sir.
Sir is about to join, sir.
Join.
Already joined.
Join.
Sir, welcome to Dr. Jenshaw Karu. Sir, is it audible?
Yeah, audible. Am I audible now?
Yes, sir. Clearly audible, sir.
Yeah, thank you.
Shall we start the session, sir? Is it okay, sir?
Yeah, we can go. Ravi.
Okay. So, good evening, everyone. So, it gives me immense pleasure to introduce our esteemed guest for today's faculty development program, Dr. Jinsa sir, a distributed expert in computational fluid dynamics and renewable energy systems. Dr. Jinsa sir currently serves as a senior system engineer at Medilicon Infotech Limited in Bangalore, where he specializes in system modeling, optimization, and thermal systems and cutting-edge renewable energy technologies. With over a decade of professional experience, Dr. Jinsa sir has made significant contributions to the design and analysis of advanced engineering systems, including solar thermal applications, transcritical CO2 systems, and turbo machinery. His expertise in the tools like ANSYS Fluent, OpenFOAM, MATLAB, and OpenModelica is complemented by his strong foundation in the developing innovative solution for complex industrial challenges. Dr. Jinsa sir holds a PhD in mechanical engineering from National Institute of Technology, Tiruchirappalli, where his groundbreaking research focused on parabolic trough collector for process heating applications. He has also been an inspiring educator, conducting numerous training sessions and workshops for academic and industrial professionals in CFD and related domains, bridging the gap between the theoretical knowledge and practical applications. Dr. Jinsa sir has authored several high impact papers in leading journals, showcasing his contributions to energy systems, phase change materials, and system optimization. His dedication to advancing engineering simulation and sustainable technology development has earned him recognition as a leader in this field. We are truly fortunate to have Dr. Jinsa sir with us today to share his insights and expertise. I'm confident that this session will be both enlightening and inspiring for all of us. Please join me in extending warm welcome to Dr. Jinsa sir. So, thank you, sir, for accepting our invitation and sharing your thoughts. Please go ahead, sir.
Ravi, whether my screen is visible?
Yes, sir. Yes, sir.
Yeah, now.
Yes, sir. Please visit.
Yeah, okay. Okay, first of all, thank you, Dr. Ravi Kumar Kotla, for inviting me for this uh, having a delivery session in this particular occasion. So, so as he mentioned, I used to have conduct a lot of workshops across academic as well as industrial perspective, especially on technology transfer, then modeling aspects, everything. So, but unfortunately today it is a no topic to me, like just an introduction section. So I was thinking what to take in introduction section because this is supposed to be a faculty development program, and all I believe all of us are faculties, and we know how things are working. Like nobody need to explain how a solar thermal system works or how a solar PV system works because those things are there in the book. So probably like mostly my presentation will be on just giving an insight into how these things are actually happening, not exactly on the technology development, but what is a crucial now. So in which area the most development is actually happening, because uh, currently even though I'm in industry, actually I was also an academician, so I know how to bridge. It is very difficult to bridge in between academy and industry. So the most problem what academicians what we face is we are in lack of knowing how what is the phase at which the industry is going and what are the technology they are going to be used in near future, and most of our research will be focusing only on long term researches. Probably that's something that is going to be happening in next 3-4 years, but industry perspective is exactly different. So what they need is tomorrow solutions, not maybe next week solution or next month solution. So regarding the green energy technology, most of the people still, I believe, don't know what actually is mean by green energy technology, because there is a lot of confusion actually happening when the name green energy or green technology. So mostly I will be using green technology because some of maybe some 75 percentage of my presentation will be on green energy, and 25 percentage will be on green technology, because that's also an important aspect. Because in the beginning session itself, I think that eminent professor have explained regarding green hydrogen. So it can be used as a form of energy, it can be used as a form in technology also. So we can discuss in a broad format. Okay, so most of the people have a misconception that whatever we are telling a green energy, they're thinking that it's a solar or a wind, or it can be a geothermal, or it can be an ocean or tech. So without understanding what makes a technology green. So the first part of my presentation will mostly on this particular topic called green energy. So before that, let us explain what actually a renewable energy and what actually non-renewable, because that's a beginning, no, for every revolution. So as we see the industrial revolution happen, this is the fourth one what we are having. So every revolution there is something difference must be there. So what is actually mean by renewable energy? So as we all know that renewable energy are something which is sustainable, which replenish, which used to replenish. But imagine fossil fuels. Fossil fuels also replenish over time. But what makes a renewable energy renewable and a fossil fuel non-renewable? The thing what it makes renewable is the rate at which it is replenishing. So renewable energy has nothing but those natural sources which tends to replenish even at a higher rate than what we are consuming it. Uh, as we know, examples are the sunlight, the wind, the solar, etc., etc., are the categorized under the renewable energy resource because their replenishment rate is much larger. Okay, and they are plentiful and they are all around us. We can make use of it to make. I'm not telling green for time being. I'm telling as a clean energy. So all these things we can make use, and we can utilize these forms of energy as a clean energy source, but not green. The green thing will come later. So, as on the counterpart, the fossil fuels, they are not considered to be renewable, even though they replenish, but it will take millions of years to replenish the same exact quantity of the fuel, whatever we are using as now. But what makes, even though the fossil fuels is dominant now because the ease at which this particular energy can be modified to some other form is very cheap now, because the technology which uses these fossil fuels has evolved in a much higher saturation rate in such a way that the use of this type of fuel makes it very cheaper and very easy and convenience for us. So that's why in almost all the field of our life, we come across any of one particular fossil fuel powered thing, even though starting from automotive to the big steel plant itself. Okay, so previously we were not cared about how harmful it is, because they are going to emit lot of greenhouse gas emissions such as carbon dioxide, carbon monoxide, etc., etc. But now we are living in an era where the energy requirement is exponentially increasing, and the concern about the environment is also it's increasing very drastically. So recently we have seen lot of policies have been taken care by the government, and not only Indian government, it's abroad also, to mitigate the issue which is related to the environment. Okay, so that made this particular technology uh, a slightly harmful side on the downside. Okay, so if you consider the renewable energy resources, we have a plentiful of renewable energy resources. I will just go to one or two slides. What are the various types, just to refresh among us. Okay, the first and foremost, the green energy, the renewable energy, what we will be talking, that will come to anyone's mind when we are telling about renewable is the solar, because the solar is the base for almost all other forms of renewable energy what we are seeing today, irrespective of it is wind, it is ocean, whatever renewable energy we are think about, some form of solar intervention is there. So solar is the most abundant renewable energy resource which is available. uh, Now the technology is mature in such a way that we can even harness this particular energy even in cloudy day conditions also. And the statistics, it is telling that almost the energy received in Earth is almost 10,000 times higher than that of the global energy consumption here. So we know how the solar energy is being tapped and being used typically for the electricity generation. The application is states from the electricity generation, because we are mostly aligned to our usage. Okay, we are thinking about the usage as an industry perspective. So the electricity generation, there are two typical technologies are available to tap the energy from the solar and convert it into electricity. So one is in the form of a photovoltaic panel, we call it as the concentrated solar power technology system. So those two are really mature technology now. So we can think about like that, the enhancement is actually happening in very smaller rate. The second
Hello, Ravi.
Hello. I think something is.
Please check it, sir, whether
Yes, sir,
speaker
we are
is
checking, sir.
Sir, there is
offline.
some network issue, sir. So he'll rejoining again, sir.
Rejoining, huh? Okay, okay. Please check it.
I'm checking, sir. I'm checking that. The internet connectivity problem is 2 more minutes. Yes. Sir, is it audible now? Jensa, sir.
Yeah, audible now, audible now. Sorry for the interruption.
Okay.
So whether my screen is visible?
Yes, sir, visible.
Yeah. So sorry for the interruption. So the network lost in between. Okay, so next important aspect is the heating and cooling, then natural lighting, then the fuel production also. So if you see the global potential of solar energy, so as I mentioned, so this is matured in such a level that now itself it have a significant of energy mix actually happening in the global energy demand or global energy supply of that. And I will show the statistics in the later slides. I have one or two statistics related to the usage, the capex cost, everything. Because when we talk about the renewable aspects, the biggest concern which is coming in front of us is the capex. It's not the opex like operating cost. It's on side of the capital investment. So solar, they have got a very good of energy mix in the energy distribution right now. So the second counterpart is actually the wind. So wind is actually nothing but wind is nothing but air in motion. So it have got kinetic energy associated with it. That kinetic energy we can tap into the mechanical energy. Then later we can convert it into electrical energy. So that is a form of conversion actually happening in wind turbine. So imagine you are seeing like a wind turbine which is the size of at least two Boeing 407 or 477 air flights. So now the technology is grown in that level now. So the bigger the turbine, you have the more energy entrapment, because as you go away from the surface, you will get a lot of wind velocity, so that can be tapped and in much efficient form. Okay, so this form of energy, the utilization of this form of energy is not a new kind of thing to a human being. As like a human civilization, it has been used even from the very last day, in the beginning decade itself for mechanical purposes. But later in 2000s, this energy is typically used in convert to electricity. That technology has been grown in 2006. So the global potential, uh, as comparing to the solar, not all these places having equal potential of wind. But if you count the total wind potential available throughout the globe, it even surpasses the electricity demand that we are having now. So most of the region having sufficient wind resources, they can support the substantial energy mix of wind in our total energy utilization in the nation. So, but the one of the major issue with the wind industry is the location. Typically, the more wind is available in locations which is remote and less accessible. Especially, you see the offshore wind turbines also. So, and we need the capital cost associated for this particular technology is enormous, which makes it enormous because of this aspect. Because the location, one biggest challenge is actually the location aspect of wind turbines. Then the next renewable energy resources that has been utilized even before solar came into picture is nothing but the geothermal energy system. Here, the energy entrapped inside beneath the earth crust is actually being used to run a turbine to generate the electricity. So that's actually the technology being used here. Typically, so the energy extracted from this particular uh, technology is more cleaner, okay, comparing to others. So can you see these two bigger things actually happening here? You know what, actually this is not chimney, this is actually the cooling tower, because it's actually being the steam is being extracted out of the earth crust. So, and that steam is being used to run a turbine. So the steam turbine in turn run the electric generator to generate the power, electricity. So one of the key aspect of geothermal energy comparing to other renewable resources are this energy itself is enough for maintaining the base load capacity of any location if it is available. So that's the biggest potential of this particular form of renewable resource. So typically two different forms of geothermal resources there. One is one name it is mentioned here. It is called hydrothermal resources. Hydrothermal resources is nothing but the steam is readily available in the earth crust, so that you just need to put a well and we can tap the steam. We can clean the steam because we cannot directly feed into the turbine because it may contain a lot of other harmful gases which can corrode the system. So typically it will be scrubbed, then will be fed to the turbine to generate power. So that actually the hydrothermal system. And sometimes the water content may not be there, but the temperature of the rock itself, it is too huge, such a way that we can utilize that thermal power. So at that situation, we may have to go for an enhanced geothermal system where we need to pump in the water and take the steam and run the turbine. So that's the second type of geothermal systems are actually happening. So in India, we do have, I think, 4 or 5 geothermal resources are available in India itself. And the next biggest actually I'm a Keralite, so if you see the Kerala side, the most of the energy what we are using is from the hydropower systems. Hydropower systems are excellent example for a renewable energy resource because it utilizes the gravitational energy available in the water, which converted to some other form, maybe it's a pressure form or kinetic energy form, and that energy can be utilized to generate electricity. So this is actually derived from, it can directly taken from any rivers, or it can be a water held captivity, etc. Anything, or a pumped like in the inaugural session, as the professor had mentioned, it can be a pumped type reservoir also. Because the advantage of this type of hydropower technology is that it can be considered to be a reservoir also. You can store energy in this one. So in that sense also you can see about the hydropower system. It is also matured. It's also being used extensively across the nations. Okay, so the other aspects of hydropower are they are being used for supply drinking water, irrigation purpose, and flood management system, and also support navigation and recreations. Then the next later energy resource and renewable energy resource that is available to us is now nothing but the ocean energy system. So as you see the ocean, the water is continuously moving. So this energy can be leveraged and that can be converted into mechanical. So the typically two types of energy are considered when we are discussing about ocean energy. That is nothing but the kinetic energy available to the water, as well as, so ocean can be considered as the largest solar receiver in the earth. So because of the more than 80% of our surface is filled with water. So more than 80% larger solar reservoir or receiver, what we can tell it as. So that thermal energy can also be utilized for the power generation. So typically, if you see the kinetic energy, available in the ocean, these are the 4 different forms of energy that can be utilized. One is the energy available in the wave. So waves are because of the wind actually. Then the energy available in the tide. Okay, these are nothing but the seasonal change and the energy, the kinetic energy available in the ocean currents. Ocean current is because of the wind. It can be because of the thermal gradient. It can be because of the rotation of the earth, whatever it is. So what is the difference in ocean current and wave energy? Wave energy is something actually happening at the surface of the water. So ocean currents are actually, it's beneath the surface of the water. So these are the two only differences. Moreover, the technology is almost identical. So whatever the picture you are seeing over here is actually one particular turbine which is being used for harvesting energy using the ocean currents. And the last one is the temperature energy. That is nothing but the thermal converter. The only key point what we need to consider when we are discussing about the OTEC plants are the temperature gradient. The temperature gradient is small, so small. So it may be like 5 to 6 degrees Celsius. So you may need bigger turbines. Typically, organic Rankine cycles will be employed. Rather than steam turbines, it will be organic Rankine cycles. Low boiling fluid will be utilized in the case of OTEC plants. But if you compare the growth of technology or the development of technology to other renewable resources, whatever we have discussed, we can tell that ocean is still in the primitive stage. It doesn't have that much of development actually happening. There are a lot of researches has been conducted in is being conducted in this particular area. The only challenging factor is the cost associated with it. And the last and the most important renewable energy resources that we use our daily life is nothing but the bioenergy. So these energy is generated from actually the organic materials. It is known as biomass. This type of energy is using extensively over a wide range of applications, starting from the heating application towards the biofuels also. Now the biofuels are also a trending field for us as a chemical or a mechanical engineer. The biofuel application is also a trending field now. So the bioenergy also we can consider in two different formats. The one is a traditional biomass, then the next one is a modern biomass. The only difference is modern is nothing but the industrialized biomass. So we will be growing the crops which is dedicated for the energy harvesting, and the traditional one is the normal natural biomass system, whatever we are having, which rural people are also using for the daily cooking practices, lighting, heating applications. But mostly the modern biomass system is actually utilized in ethanol or biodiesel generation, etc. Okay, so we have discussed a wide spectrum of renewable energy technology so far. Something like it's replenished at a much higher rate, at much faster rate, and we believe that all these are clean. Yeah, the PV, if you say that it is clean, photothermal system, it's clean, wind, it is clean, but then why the green comes into picture? So what is the difference in between that? So whether all these renewable energy resources are green or it's a clean energy resources, whether any difference is there in mentioning the name? Okay, so I'm writing this as a clean energy or green energy or renewable energy. What is the difference in between these three? So one thing common in all the three is that the interest what it is getting to all these technology nowadays, because of the higher electricity demand as well as the concern about the environmental pollution aspects and the lack of fossil fuels. Now the phasing out of the fossil fuels, especially coal, gases and all, these technology have got immense attention. That one thing is common, but what makes it different? So that's the question now. So why a renewable may not be a green? All renewable energies are not green energy, so that we have to first keep in our mind. So a simple example what I'm giving here is actually the example for a biomass energy utilization using an organic material used for power generation purpose. Okay, so you imagine, even though we are growing for industry purpose or industrial agriculture, whatever we are telling, it may have issues in cutting down the forest or cutting down the natural vegetation, whatever is actually happening. So we leave that side. It's an environmental impact which is caused by the biomass resource. The second biggest concern about it is the carbon dioxide emission. Okay, so without any sustainable or without any green or so-called green technology, the natural combustion of any biomass system is inefficient. It have a side effect that it emit lot of unwanted gases to the ambient. Say for example, a significant carbon dioxide emissions are there, which can contribute to global warming. It can cause deforestation. It can cause air pollution from the particulate matter what it is released during the ineffective combustion of that one. So even though we may think that this is a clean resource, so imagine the impact it is giving to the ambient as well as giving to the uh, environmental aspects. So in order to gain a particular technology or particular energy to be green, it should not have these kind of effects. It should not harm the environment. It should not leave any of residual like global warming gases to the ambient. So that is the thing which differentiate a renewable, a clean as well as a green energy. So we can conclude that while biomass is technically renewable because it's replenished at a much faster rate, it is sustainable, but an unsustainable practices make the positive negative. So it have a negative environmental impact. So it is not truly green. Okay, but there is a way to make it green. Okay, so the green energy, the definition of green energy is slightly different from the renewable or clean energy. Okay, so the definition of green energy is nothing but the energy that can be produced using any method or process or from any sources that should not cause us any harm to the natural environment. It should not emit greenhouse gases. It should not create any harmful, not only greenhouse gases, it should not also create any environmental impact. So this is the difference in between the definition of three terms that we are used now. So clean is air. We are telling about ambient condition. So it should not have process. It should not give any greenhouse gas emissions. Then the next step, the green is not harm to environment plus greenhouse gas. The renewable is just a replenishment. We are not telling that this is creating any harmful effect to environment or not. So altogether will create a green energy resource. So we can conclude that not all green energies, maybe all green energies can be renewable, but not all renewables cannot be a green energy technology. Okay, so far we have discussed a lot of renewable resources that can be considered to be green, or that may require little bit extra care to convert that into green resource. But whatever it is, how we can find a particular energy resource is the most efficient or not? Is it by calculating the efficiency of the system? Say most of the people like academicians or researchers, we are interested only calculating the efficiency or efficacy of a system. But is that efficiency calculation is enough to quantify that particular technology to be green, or to categorize which one is better, which technology is better than other one in terms of green? Okay, so that particular term what we have to use here is nothing but the levelized energy cost. It is not just the efficiency of generation of energy, it is a levelized energy cost. And one important aspect you have to keep in your mind, that there is no standardization as such. Nowadays, everyone is talking about green carbon dioxide emission, carbon absorption, carbon capture, carbon disposal system. But as of now, there is no standardized, or there is no standardization is available to categorize one particular technology as this is 5-star rated green technology or 3-star rated green technology. That will come eventually, because this is just a beginning. People are moving towards that one. Industry is moving towards that one. Not only the energy industry, but almost all industries are moving towards this particular technology, or this particular word, the green, because of the stringent policies imposed by the government. As of now, it's not actually happening not only in India. It's a global phenomena that it is happening. And the most important thing you need to understand is, while categorizing it as a most efficient or least efficient, it have a lot of dependencies. Other than the technology, it have a lot of dependencies over the location, it have a dependency of the resource availability, and it also have the dependency on the technological advancement, what that particular technology is being used. So the one typical term that we can use to categorize which one is better than the other is using the levelized energy cost. It's actually a relative term, not an absolute term. So this is almost equivalent to your OPEC capex calculation, but it have one more key identifier is there along with your OPEX and capex. That is nothing but the environmental impact during the creation and operation. So it is nothing but the life cycle assessment of that particular technology. You have to consider from the birth to the depth of that particular technology, where for example, if you are making a solar panel and you are using that for 30 years, you have to consider from the very scratch of manufacturing stage to up to the recycling stage to evaluate the levelized energy cost of that particular PV panel. So that level of calculation is required to identify whether the system is most efficient or least efficient. Typically, people used to have one typical term called EROI. So this is nothing but the energy recovery index over the lifetime. Okay, so it's a recovery index over the lifetime. It is nothing but the ratio of energy output over the lifetime to the energy invested in production, installation, and maintenance. So it underscores everything. So we have to consider the production, we have to consider the installation, as well as we have to consider the maintenance also to calculate the EROI. So it will be very surprising to you which one is the most efficient green technology. So people may think that it is solar because the solar is having the lion's share in our energy mix, but it is not solar. The most efficient energy, renewable energy as a green energy is nothing but the wind. Because if we calculate the EROI of a wind turbine, it have got 11.64. That is almost 10 times, 100 times than the investment cost. So this is not the efficiency. Okay, this is not the efficiency of the wind power. This is the life cycle analysis efficiency of the wind turbine, starting from the investment cost up to the depth of the turbine. So how much investment we have in terms of energy and how much energy that it can generate, it's actually almost, you see, 11,164 percentage return is available for wind. So wind is the best renewable resource in terms of green. So the only carbon emission activity which is actually happening is at the production stage, but the technology is changed in such a way that can also be mitigated through different types of processes we can utilize for manufacturing it, and the various type of material that is being utilized in that one. The second one is actually the geothermal. As I already mentioned, this is one of the green source. But why it is being second is because of the carbon emission it have at the stage of production. So it have got immense structures, it have got the turbines associated with it, and the carbon and the energy, and those processes are very energy intensive process. What I'm telling is the mechanism or the machinery which is going to be used for geothermal plant, it is actually energy intensive process for that one. So that make it as the second most efficient green energy resource, and it have very low environmental footprint and minimal operational usage after installation. You don't need to put anything into this one because the steam is already available. So it's reliable. It can provide the base load energy with high efficiency. And the third one is the hydropower, the same as similar to geothermal energy, the hydropower. But the only concern why it is on the third place is because of the concern with the environmental impact on creating the water bodies like the dams and all. So maybe deforestation can be done. So it will cause a sustainable or ecological issues at that location, but that can be tackled if you're considering instead of large scale system, if you're considering small scale systems like a distributed power generation, hydropower plants, then that issue can be mitigated to an extent. And like the geothermal system, you don't need to spend extra anything for using that one because the resource is freely available to you. And the fourth one is the nuclear energy. So what makes it most prominent is a very high energy output of that one, and it is not strictly any renewable, but there is a debate is actually happening whether the nuclear can be considered to be renewable or non-renewable. But why it have got immense attention is the energy density available with that one. So that energy density available with nuclear is so immense that it can outperform even PV or thermal, whatever normal thermal power plants, whatever we are seeing nowadays. The most advantage of nuclear energy is it doesn't have any greenhouse emission. It doesn't, but only concern is the how you are going to dispose the waste. And the last one is the solar power. So this is actually the ranking for the resources, if we are considering it as a green, why solar power is coming at the last? So have anyone knows the answer of that one? Okay, solar also, we may think that's a green geothermal energy. You can approximate it to be a geothermal energy system because you don't need to spend anything at the utilization stage or at the operational stage. If you compare the investment cost nowadays, it's even lesser than geothermal energy. But why solar power came to last? The solar power came to last. We'll come to that point, why it is at the last. Okay, so the next question, what is the concern? Why we are talking about green energy? Just renewable is more than enough for us. No, the green energy consideration is actually in picture because of two aspects. One is the climate change. The second one is the energy mix that we are going to have in the future. Our nation cannot survive with the current transmission line system, whatever power generation system or that power management system, whatever we are following nowadays. In future, no centralized power generation plant cannot survive the energy demand of any location. So we have to move towards distributed energy resources. So it not just the green consideration, it also have other aspects which makes this particular technology a little bit more attention nowadays. So the transformation from the normal traditional system, whatever you are using now, and to the emerging system is very different. The complexity of the emerging system is very different. Okay, so we can think about these, just think about these two drawings. Okay, in traditional system, it fair and well, it is a one-way energy flow. So in one place, the power is generated in a bulk rate. It can be a thermal power plant, or it can be hydro power plant or nuclear power plant, whatever it is. But the utilization will actually happening at another location. But there is only one directional energy flow is actually happening. So this is the traditional or the power generation and the technology, whatever we are experiencing in nowadays. There is no interaction between any energy sources or any energy users. There is no interaction at all. But this cannot sustain the energy demand in the future, because the energy demand in the future, it is not going to be a steady one. It is going to be very chaotic, a very random nature. So we require a very sophisticated grid system to tackle that issue. So the modern energy system has to be, as I mentioned, it has to be very dynamic. It has to be multi-directional network. So the only possible ways are by following these 5 points. The one thing is the integrated energy resources. We cannot consider a single point energy source in future. It has to be distributed. It has to be integrated one. It requires multiple energy resources, say like solar, wind, geothermal, bioenergy, whatever it is. And there should be links between these resources and the usage sector in a holistic approach. Whether it is being used for electricity or industrial application or transportation application or heating and cooling purpose, whatever it is. The second most important fact for this particular transformation or the challenge what we are going to face in the future is nothing but the decentralized energy generation. So as I mentioned, it has to be an integrated energy source. It has to be decentralized. So for example, if 10 megawatt power is required, maybe in future you can see a distributed power generation source dedicated to one city alone. It may not have any link with other energy resources. Okay, so small scale rooftop things are coming into picture. So we can generate individual participation in that. Then the third one is the smart grid and digitization, and the most important other aspect is the energy storage solution. The importance of energy storage solution, I think the professor have mentioned in the beginning, because it has to be dynamic. And electrification across sectors. 100% electrification is only possible through decentralized energy generation. It cannot it cannot possible through centralized energy generation as in the traditional system, whatever we are seeing now. So it is not just because of the climatic change. What I'm just consolidating the point, whatever we are discussed, the transformation is not just because of the climatic change, but it also give an opportunity to build a more sustainable, efficient, and equitable energy system that benefit everyone. So that's why in the beginning, in the previous slide, I have shown you that the last point, complete electrification. So another one advantage, okay, the advantage is like by embracing these technologies, we can provide a cleaner and more connected energy for the future, which does not harm our environment. Okay, so the next few of the slides, I will explain what is the current trend, the most important trend, which is read along with the green technologies, whatever it is actually happening now. So it is not only limited to energy sector, it also limited to industries also, where manufacturing aspect also are considered, manufacturing plus transportation, etc. Okay, so this graph is a very vital, this graph is giving a very vital information about how much industries is investing on this particular technology. So this graph actually it is plotted for 2023-24 yearly plot. But if you extrapolate that one, okay, so as of now almost 800 billion at the end of 2024, a total of 800 billion has been invested on the green or the clean energy technology itself. So which is projected to be around 1 trillion at the end of 2030. It is not just the picture in India. Whatever I'm explaining is actually the global, because the technology is actually growing in global, not just in our nation. It's a global phenomena. As an academician, we have to embrace that global nature of that particular technology. Okay, so we can see that the line share almost between 2023 and 24, almost the investment have been grown up to some 20% if you calculate everything. But the line share is towards the solar PV system. So why it is towards solar PV system is just because the technology is very mature now, and the material which is available now is actually it's actually overdone. We can consider that its excess are there, and since it is very excess, the cost have been cut down very drastically. I will show that picture in the next slide. So this given a slightly give a bigger advantage is solar PV. The next second most investment actually is happening on the onshore wind turbine. Okay, but what you have to find, okay, you may think that the last two, one electrolysis and carbon capture and storage, they have got very less share, but you just see the growth of those two technologies. Electrolysis, the growth of electrolysis in 1 year, and similar to that CCS, the carbon capture, and it is written CCUS here because carbon capture utilization and storage is coming, but here it is carbon capture and storage only plotted. What is utilization we'll see later. These two technology is evolving at very higher rate. So if somebody want to build a career in this area, this is the right moment. You can embrace these two technologies. As of now, there is no CCS plants are there in the world. So it's going to be something like in next year at the end of 2025, it is planned almost 150 electrolysis. Electrolysis, wherever electrolysis is mentioned, it is about the hydrogen generation. Okay, you imagine it as hydrogen generation. So almost 150 hydrogen generation plants are being planned worldwide. Almost 60 plants in carbon capture, storage, and utilization is being planned across the world. So that's the rate. That's the rate at which these two technologies are evolving. So where the hydrogen is considered as the future fuel, but then what is the advantage of having the carbon energy technology like carbon capture? I will come to that one. Okay. So there are a lot of policies and regulations are being evolving in these two particular areas, especially in the area of CCS plants. So these drive big pipeline in the project. So next decade, you will be seeing a lot of development is going towards these two particular area, that is electrolysis as well as the CCS plant. So CCS is very niche like it just it's not up to that stage of even hydrolysis or electrolysis for your hydrogen generation. And similarly, if you evaluate the capex cost for the clean energy technology, whatever we have seen so far, you can see that this graph, the capex cost for uh, individual uh, technology, especially say solar PV, there is a drastic reduction in the capex cost actually happened over the decades from the 2010 to 2030. So this is a projected one is there 2024 to 30. So that's the reason why solar PV have got a lion share, almost 55% of the total renewable energy is shared by uh, the solar itself. This is actually the statistics of recent 2024 statistics. Almost 55% of the total energy mix in renewable is from solar share. So the main reason is the reduction in the capital cost. So the capital cost has been declined so far, and it is expected that the capital cost declination is almost 15 to 25% by 2030. But if you see the last two, electrolysis and CCUS, carbon capture and utilization storage, you can see that instead of the capital cost is being decreased, the capital cost is actually higher compared to the previous year. This is because actually the plans are being evolved and the technology is getting evolved, and we don't have much grip on the technology in such a way that we can clearly mention that the operational cost is going to be this much, or the capital cost is going to be this much. So these two technologies are in the development phase. That's why in recent trends, if you see the CCUS and electrolysis, the cost, the change in capex is not justified. And the second most thing what you have to find from this particular graph is actually the cost for the onshore wind turbine and offshore wind turbine. It's also increasing. Why? What is the reason behind that one? We already mentioned that, okay, the capital cost for a wind turbine is so huge, but if you consider the return of investment, wind turbines are having the most return of investment that already we have seen. But why it is not that popular like a solar? Why it haven't got that much of acceptance? It have got acceptance. I'm telling that why it is not that much popular like solar. So the reason is that the cost reduction is the one reason for the cost reduction is whether the component can be mass produced or not. Almost all the components which is going to be in any solar plant, irrespective of it solar thermal or solar PV, it can be mass produced, but it is not true for the case of wind turbines. The wind turbine components cannot be mass produced. So that's the main reason you find that the bars are almost in same line. It is not decreasing in a much larger extent. Okay, so that's actually one of the issues in wind turbine industry. Okay, so the next biggest word what you used to hear when we are dealing with the green technology is the decarbonizing. So this is also the trend now, because in the beginning I already mentioned that all renewables are not green. It will be green only when it have a positive feedback on the environment as well as the greenhouse gas emissions. So the carbonization, carbon dioxide emission is a fact. Okay, so people, like if you see the 10 years back, people used to think that all renewable, it won't harm the nature, but it is not the case. So that's why the renewable industries is being scrutinized overall past decade for generating low carbon. It's a myth. It's not going to happen because we are not considering the energy intensive part of the value chain. That is nothing but the manufacturing process. So why PV is at the least in the list is because almost 90% of the carbon emission is for any PV industry is actually happening during the energy intensive or electricity consumption stage it is nothing but the manufacturing process. It is at the stage of manufacturing process. It not just because of the manufacturing process, it also because of the materials being used for manufacturing a PV. We have to do mining. Mining is the biggest concern about the environmental impact. And the materials, whatever the materials which is being used for manufacturing PV. That's why we are moving towards advanced type of PV technologies. You might have already seen. I have seen a lot of names in the schedule, so I'm not going to explain those things now. You might have seen perovskite, organic PV cells. So these things are coming to picture to make PV green. Even though it's a renewable, we have to make it green. So these are the effort which is being taken to make that particular technology green. So the two key opportunities or concerns that you have to consider to decarbonize not only the renewable or energy industry, but any process, is you have to look into two aspects: whether the manufacturing process is clean or not. Because almost all the manufacturing process, whatever we are seeing, especially in the steel industry, whatever you are seeing, is very energy intensive process, and it will be using a lot of fossil fuels also in that. So whether the manufacturing process, whatever we are using, especially for manufacturing the components for renewable, is green or not? That's the first question you have to ask. So this is a typical classical example people used to tell when categorizing renewable and green is about the PV manufacturing process. Almost 90% emission stems from the manufacturing process itself. The second biggest question you have to ask is, whether the technology or the material, whatever we are using, is green or not. Say, like example I already mentioned, for example, for PV, we are using polysilicon or silver. Reduce the usage of silicon or silver because that has to be mined. The process which is going to get polysilicon or silicon material, silver, is an energy intensive process. It is supposed to use a lot of fossil fuels or a lot of carbon emitting methods in that one. So whether is it possible to reduce those usage of those materials, even though if you are using those materials, in another way you can think about is whether you can recycle those materials. Okay, I will come to that one later. So that is also one of the typical practice which we used to call, like when we are dealing about decarbonization or green industry. Okay, the example is now the perovskite things are evolving, organic PV cells are evolving, etc. Even the batteries also, developing the batteries with the sodium, molybdenum, cobalt batteries, we have to reduce that. We have to reduce because those are really resource intensive technologies, and we have to explore much into LFP batteries like lithium iron phosphate battery or gravity based battery or sodium ion battery or flow battery, whatever it is. So, okay, so these things makes the technology green. Then how we can convert it into that one? So that's actually biggest question. So the only way by which we can impose this particular technology or we can drive demand to the technology is through policies only. So I am quoting two important policies which is taken by the European government in recent year, 2023 April month. Because if you see the green concept, the Europe have got the lowest average carbon intensity of the power system across any global region. That's why I quote the two particular policies that it is being taken by them for reducing the climatic issues to promote the green. The first one is the carbon border adjustment mechanism, CBAM. They used to call it the CBAM. So it will be very interesting to know about this particular policy. So it stringents whatever energy intensive manufacturing component which is imported to Europe should have a CBAM certificate. It's similar to whatever in India we are having the green tax, but our green tax imposed to Indians, but this is imposed to the imported commodities. So in one way, they are trying to reduce the carbon emission in Europe, as well as it imposes to the other countries, non-European countries also, from where these components are being shipped to the Europe. So in this particular policy is beneficial in two different ways also. And the second biggest policy that recently they have considered is a new battery regulation, because knowingly or unknowingly, batteries are the biggest commodity that we have, that have the carbon footprint, because everywhere it is there, because that is the cheapest energy storage technology that is known to us. Everywhere we are using that one. Okay, so this particular battery technology regulation, which promote a cleaner and sustainable solution in such a way that you have to mention what is the carbon footprint of your particular commodity in that one. So the advantage is it promote cycle carbon utilization. Cycle carbon utilization is nothing but, imagine you having a battery, you manufactured it, you are using it. We know that it cannot be used for lifelong. It have something called an expiry date. So when it is of no use, this particular regulation mentions that at least this much percentage of materials which are harmful to the environment must be recycled from that one. So that is the policy regulation for battery, because the future is battery only. The future technology development in whatever the storage technology we are dealing with is on battery only. So these two policies are a good example which tells about how the policy can make a change in the industry perspective. The second one is the growing demand of, now people are also aware about the issues which are happening in the climatic changes. So even people are also aligned towards the demand for say decarbonization techniques, or something we call it as low carbon products. Okay. So as of now, we have discussed about the green energy utilization. I will just give a glimpse into other sector also. Say in industry also, the most industry sector which emit the highest carbon emission is the steel and cement industry, because they are very heavy energy intensive industries. But through certain activities, implementing certain technologies, we can even convert that steel and cement, whatever the industry it is, towards a green industry. So one of the biggest thing what we can use here is the use of hydrogen based technologies. Okay, apart from using fossil fuels for their usual energy generation, they can consider hydrogen based technologies. Imagine, we cannot always tell that all the process is 100% clean. That means all the process are not emitting carbon dioxide. There are processes which is supposed to emit carbon dioxide, but we can capture it. We can store it, and we can utilize it. If we are implementing that perspective also, then we can consider that particular industry as green also. So that's why in that picture you have seen there is a drastic growth in the technology evolution or implementation in the CCS plants. This CCS plant growth is not only happening from the green, it's also actually happening from the industry side also. We cannot make all industry 100%, 0% carbon emission. It will emit carbon dioxide. But if we can capture that one, store it, and whether it can be utilized for some other activities, or we can store it, and we can put it to some, like say, to put some sum which is not going to have any issue in the environment. That also be a green kind of technology that we can think about it. The second most important emitter of carbon dioxide is the mining industry. I will come to this one. What are the various ways? We will take this as an example, because this is most controversial example people used to see. So how we can consider a mining industry? How can we convert a mining industry to a green mining industry? So what are the various technologies we can focus on that? So the first important concept what we can do is a decarbonization. Okay, anyway, there is a possibility to emit carbon dioxide. So whether we can implement any technology which can capture the carbon dioxide, which can utilize it, or we can store it, so that can offset the emissions. Okay, if we can offset in short word, if we can offset the whatever emission it is having, that is good. That we can call it as a decarbonization. Okay. So another method is to use electrified fleets, or say, imagine like mining industry is the place where most of the heavy machinery is being used, which are fossil fuel driven. If we are able to make it electrified, or we can make it hydrogen, based on hydrogen fuel, that also give a plus point. And the third one we can for using the decarbonization is whatever the electricity we are using in mines, whether it can be supplemented from any renewable resources like solar, wind, or hydropower, that can also give an advantage of converting a mining industry to a green. The second important thing is to have a proper water management. The biggest concern is the recycling of and reusing of the water, so that must be implemented, so it minimizes the contamination that it is going to happen for any water bodies nearby to that one, or utilize in a desalination plant, which can help in preventing the use of the local water reservoirs. The third one is the waste management. Okay. The next one is the biodiversity conversion. Anyway, for mining, we need to go for deforestation or habitat disruption. Whether we can restore the forest in somewhere else, or we can implement a biodiversity offset plan to compensate whatever unavoidable impact we are going to give to the environment. So that can also lift the mining industry to the green name. Then the next one is the efficiency, energy efficiency. We have to use the smart technologies like automation, artificial intelligence, or IoT devices to have an optimized usage of energy. And the next one is a sustainable resource uses. That is what I mentioned previously, circular economy principle. So the reuse, recycle and reuse have to be implemented. This is not only applicable to any mining industry, it currently applicable to the battery industry also. Whatever battery we are using, and people, the government, the policies will be given to recycle and reuse the material at any cost. Then the last one is the community engagement. We have to make the partnering of the local community about the sustainable development initiatives. We have to educate them to promote the sustainable mining practices. That these are the key concepts what we can consider to convert even a high non-green sector to a green sector. This is possible. Okay, so we have to augment the technology whatever being used in such a way that it will benefit not only the energy efficiency side, it also benefit to the environment, it also benefit to the ambient also. Okay, so the next biggest question, the biggest word whatever we used here when we talk about green energy or future fuel, it is the hydrogen. Because hydrogen is so cheap, it is abundantly available in the ambient, but what makes it most issue is the kind of storage mechanism we require for the hydrogen, because it's a flammable gas. And the transportation, how we can, it's a gas actually, how we can transport it. It cannot be easily liquefied as comparing to LPG. Okay, LPG is also gas, but the transportation is not that hectic because LPG can be easily liquefied, but hydrogen is not that much easily liquefied. Even carbon dioxide can be liquefied even better than hydrogen. So those are the concerns which make this particular technology investment intensive. So it have also another side also. There is a lot of scope for the research and development. Whatever people are starting their research, there are a lot of opportunities are available in this particular area. Even the most MNCs are also looking towards this particular area. In company, we do have a lot of activities going in this carbon hydrogen, low carbon hydrogen, or green, so-called green hydrogen scenario with other MNCs also. Okay, so what actually green hydrogen? So why it is not simply hydrogen? What is low carbon or green hydrogen? If you search about the hydrogen, you might have heard about another word, blue hydrogen. Somewhere it is called blue hydrogen or blue ammonia. It is written over here, blue ammonia, or low carbon or green hydrogen. Both are almost identical. Okay, so it's gaining so popularity because of how easy this particular gas can be converted to any form. It can be converted into fuel. It can be converted easily into other chemicals, which is mostly being used in industry right now. Say, for example, ammonia. Ammonia is being used in refrigeration system, and most of the industrial process industries are also using ammonia. Methane, it can be easily converted into methane. So that give an upper hand for this particular gas being used as a fuel. Okay. So what is low carbon hydrogen? So typically nowadays the hydrogen is actually produced either through steam reforming or through electrolysis process, but thermal process is mostly used now. So methane is being used using steam reforming of hydrogen is produced using the steam reforming of methane. But the problem is one of the byproduct of that particular process is carbon dioxide. That cannot be fed to the ambient. So what we can use is whatever hydrogen which is producing, that can be captured in ammonia and can be stored in ammonia form, which can be easily converted back to hydrogen. And the carbon dioxide, wherever it is producing, that can be captured and stored, which can be utilized for some other purpose. That's why it is called low carbon hydrogen. It doesn't mean that it won't generate hydrogen. It will generate hydrogen, but it will generate carbon dioxide. It will emit carbon dioxide, but that carbon dioxide can be trapped and utilized for some other activities. Then we can call that particular hydrogen as a low carbon or green hydrogen, because it's not affecting the ambient condition. It's not affecting the environment. So where this carbon dioxide can be used? That's the next question. Carbon dioxide have a wide variety of applications now. One typical technology development which is actually happening is in the enhanced oil recovery. So what they do is they will liquefy the carbon dioxide, they transport through the sea, and they will be using the rig where this carbon dioxide will be fed to the well, the petroleum well, whatever it is, to enhance the oil recovery. And this carbon dioxide will be stored at the seabed. So that is one of the technology which is actually happening. Now we have projects running in that sense, CCS, carbon capture and storage. The carbon dioxide can be transmitted not only in the liquid form, it can also be transmitted through gaseous form, through pipeline systems also. That is also possible. Say if the wellbore is near to the seashore, if the wellbore is far away from the seashore, typically it will be transported as a liquid carbon dioxide. And the second one is it can be stored within the ocean itself. How we can be stored within the ocean? The sea can absorb carbon dioxide and hold it, but in order to enhance the absorption capacity, we need to add minerals to the sea. So if we add minerals to the sea the ocean can also act as, I will come to that one, what are the different methods for capturing that one. And even it can be utilized for generating other fuels. Even nowadays, another trend it is evolving, it is called the green refrigeration system, where one of the refrigerant is carbon dioxide. But the problem is where it is being used. It cannot be used frequently in the world, in everywhere in the world, because if you see the critical temperature and pressure of carbon dioxide, it's very low. It's comparable to the ambient temperature of some places. So where we have to operate the carbon dioxide, whether it has to be operated subcritical state or supercritical state, it depends. But the cost of the technology is too high. We have experience in developing transcritical carbon dioxide refrigeration system as well as heat pump system for industry. Okay. So what are the major use of this low carbon hydrogen? So as I mentioned, it is a future fuel. Why? Because of these three aspects of hydrogen. One is ammonia production. So hydrogen is the critical input for producing ammonia. So ammonia is the predominant material which were in the fertilizers, the most produced chemical. So typically, traditionally, ammonia is actually produced to form natural gases, and we know it can emit carbon. It can have carbon emissions. So usage of this low carbon hydrogen, or also called green or blue hydrogen, can eliminate these drastic emission issues related to the ammonia production. The second one is a synthetic methane. So methane is nothing but a fuel which can be used for heating, electricity generation, industrial processes, etc. So the advantage of methane is it can be used as a replacement for the natural gases. You don't need to change the infrastructure for of the combustion system much. You can directly use that one with the fewer changes in the system. So that's one of the main advantage of using a synthetic methane instead of a natural gas. So by combining the carbon dioxide, whichever we stored, again using the same hydrogen, we can produce a methane back. Okay, so that can be used. Then the next one, third one is a synthetic e-fuels. It can also be used for producing some of the petroleum, synthetic diesel, gasoline, jet fuels, etc., which can be used in transportation. So you see, it can not only coin towards the industry sector, it can coin towards the agricultural field, it can coin towards the transportation sector also. So that's the reason why this particular technology is gaining much more importance recently. Okay, so far we have discussed about the green aspects and what is decarbonization and how we can make one particular technology green. The only thing is the only method is decarbonization. Okay, so the next question what it comes to mind is carbon dioxide removal. How much we can remove it? That's actually the biggest question. So carbon dioxide removal is nothing but the technology which has been used to remove carbon dioxide from the atmosphere. That's all, in simple way. CDR is nothing but the technology which we use to remove carbon dioxide. But why this technology is needed? We just record decarbonization. But then why we are thinking about CDR? Whatever carbon dioxide is produced, that can be captured and stored. You see, in that sense. Then why we are thinking about, again, we are thinking about technology which required to remove carbon dioxide. This technology is required because already our ambient is having abundant carbon dioxide with us. So we not just decarbonize the technology, not only decarbonize technology, but also we have to capture the residual carbon dioxide, whatever it is available in the ambient for time being. Why? Because the first biggest aspect is the meeting climatic changes. Okay, so our climatic goal is to limit the global warming in the range of 1.5 degrees Celsius to 2 degrees Celsius. It cannot be attained just by decarbonizing. We have to do carbon dioxide removal also to attain this particular range of global warming that we are agreed. The second thing is, I already mentioned, it is offsetting the residual emissions. Whatever it is available right now through transportation or agriculture industry, aviation industry, because it is very difficult to convert any aviation. Imagine how we can convert any aviation industry or a marine industry towards green. It's very difficult. It's very difficult to convert an aviation. Those are like highly energy intensive transportation technologies, but it's very difficult to convert those to green. So there must be some residual carbon dioxide will be left. The decarbonization itself does not give an upper hand to bring back the global warming to 1.5 degrees Celsius to 2 degrees Celsius. We need to remove the historical emission to reverse back the environment. So that's why the CDR is actually come into picture. So if you want to strive for a net zero emission, not only decarbonization, CDR is also plays a crucial role in offsetting the emission from not hard to abate sectors, especially like the steel power plant, aviation industry, marine industry, etc., whatever I mentioned. Then what are the basic methods which we can use for decarbonization or carbon dioxide removal? The first one is the natural based solution. Some of the things I already explained. The one is the afforestation or the reforestation. We have to plant because plants are the biggest thing which can be used for absorbing the carbon dioxide. So one method is to afforestation or reforestation. The second one is the soil carbon sequence stratification. So this is the ability of soil also have the ability to absorb carbon dioxide. But if you want to increase the rate of absorption, what you have to do is you have to plow the soil. That's all. Like whatever during the cropping time what we are doing, these are natural, but it will take time. It's actually time bound process. Then blue carbon ecosystem, like developing a coastal ecosystem like mangroves, seagrasses, salt marshes, etc. Because these marshal plants are very known for their high efficient carbon capture. So these are the natural based solution. Apart from the natural based solution, we have the technology solution, technological based solutions also that people are talking now. The one is the direct air capturing system. Then the next one is the bioenergy with the carbon capture and storage, and the last one is enhanced weathering. Okay, so direct air capturing utilizes technologies which can absorb carbon dioxide from the atmosphere and store it, which can be transported or it can be utilized in other products also. Similar to that one, bioenergy with the carbon capture and storage, combining biomass energy production with the carbon capture to sequence emission, like example like char, biochars, etc. We have technology running using bioenergy technologies for carbon capture. We are having one pilot plant. We are actually experimenting that pilot plant based on bioenergy. Then the last one is enhanced weathering technology. Then the third one is actually the ocean-based system. So what we have to do is we have to improve the alkalinity of the ocean by adding minerals to the sea, which can increase its capacity to absorb carbon dioxide. The next one is a seaweed cultivation. We can cultivate seed, but whatever we are telling it have a negative side also. So that also we need to consider while implementing these technologies. But to be frank, at the end of 2024, almost all the development is actually happening in technology based carbon dioxide removal rather than the natural based, because natural based carbon dioxide removal is not actually a good technology for today. It will take time to do that. So most of the development is actually happening on the technology base, especially the first one, direct, especially from DAC as well as BECSS. So these are the two important things what actually happening now. You can see from this graph over the year from 2021 to 24 how much growth in the number of projects have been implemented using the direct air capture system. It's growing very fast. Okay. So these are the things regarding the green energy system. Since we are dealing with energy, we have to discuss about the virtual power plant, because we already have mentioned about decentralized energy systems. We already discussed that one. So we have to I will tell you a glimpse about the virtual power plant. This is nothing but the future energy management system that we are going to experience in the future. So in future, the energy management system will be like a virtual power plant. We may not be having a full-fledged single power plant at one place, which is supplying indefinitely energy to all the location. Instead of that one, the grid operated system will be there, where the flexibility in demand and supply will be there, because we're having a distributed energy resources, which can be from wind, or it can be thermal based systems, or it can be PV based system, all connected to the same grid, where one software system will be there implemented, which will manipulate how much demand it is there in particular location, or how much generation it is there, which can offset, and we can manipulate these two activities, that the demand as well as the supply. So this is nothing called virtual power plant. Why it is virtual means there is no power plant as such, because as a user you don't need to worry about it. As a user you experience a power plant, but as a source it is not just a power plant. It's a distributed source of energy. So this is actually what typically the electrical people used to tell the smart grid. The grid's a smart grid system. What is the main objective of the VPP? The VPP's main objective is to monitor, forecast, and optimize the trade. Whatever the energy which is coming and whatever the demand we are having, we have to monitor, forecast. Why I am telling all these technologies is that these are the need for today. And as academicians, you have a lot of time to invest your potential in these areas, so that you can give something back to the industry. So what is the advantage of monitoring, forecasting, optimizing? So the main advantage is to give away the fluctuations. So it can give away the fluctuations in generation as well as the consumption side. Apart from giving away the fluctuation, it can precondition the grid also. The precondition the grid means, say for example, your home will be having one PV plant kept at the rooftop, but your rooftop power plant may not be sufficient to uh, meet the base load demand of your home. Okay, so it have to supplement from other resources. Okay, so that is actually called preconditioning. So it can act, it can think and act, it can think and act accordingly. And if some otherwise the problem, like the problem, okay, imagine that it can meet the base load, but the problem is that if your base load is varying very dynamically, your system is also going to operate very dynamically. So the dynamicity will create some issue with your system. So the VPP plans, the VPP can precondition in such a way that the dynamicity can be negated. So that's actually the point where called the preconditioning. So monitoring, forecasting, optimization is not only the one single most objective of any VPP. The most important objective of the VPP is the preconditioning. Okay, so it can deliver the same service and with the same redundancy and substantial trade on the same market as a large central power plant can do. So as a user, you don't think it as coming from, you may get from your neighbors PV also, but you don't bother about it. Okay. So this is the last topic. I will finish in 2 minutes because since I'm discussing about the academics as well as the I don't know whether you came across this particular chart. This is called the technology readiness level. We have a lot of PhD people coming out of IITs, NITs, etc. But the problem is like the industry is not gaining much out of them. So why? Because most of our researchers are actually coming at these three. This is nothing but the technology readiness level. Our academic researchers are actually up to TRL 3 only. But what industries are focusing is from 7 to 9. Actually, there's a gap in 4 to 7. Okay, 4 to 7. So why I'm showing this one is, I think this is a community. I can show this exact graph. If you are interested to work on this particular green energy field, don't look into the basic research, say something like how a PCM can solve this issue. No, you may test in a test tube and think that okay, this works fine. It doesn't matter. It doesn't matter to an industry. You have to develop this your project in such a way level that you can transfer the technology to the industry and the industry can readily take it. So your testing, everything has to be in that range. I will show you some of the tools that you can use for in this particular area, especially in green systems. Here, the CFD, those kind of things won't work. It will work only in the physics level studies. In the system level studies, it won't work at all. So if you are interested in the system level integration, modeling, optimization, then you have to learn one particular area called the system modeling or the model-based design, MBD. Okay, there are immense number of softwares are available. Some of them are free and some of them are paid. Among these softwares I mentioned in that one, Energy Plan is free, Open Modelica is free, but Aspen Plus and all it is paid. MATLAB Simulating is paid. So all these softwares you can use for having a system level modeling, a system level optimization. If you are interested in optimization, there are wonderful tools available in Python. I can just name one. It is called Pyomo. You can use it for dynamic optimizations also. So bring your research in that level such that you can directly gain from the industry, and your research also will go into ruin. No? It will be using somewhere. It won't be just in paper. It will be in reality. So your research you can coin in that level. So my final thought is that green energy transition is not just reducing carbon dioxide emission, but also creating a resilient, efficient, sustainable energy system. You have to think in 360-degree to create a green energy transition system. It's not an easy task. There are a lot of opportunities available. And investing in innovative technologies, fostering collaboration, etc. As I mentioned, aligning academic research towards industry, we can accelerate this shift from clean renewable energy to ensure a sustainable and prosperous future for all. So with this, I'm winding off my discussion. I know this is very little to be given in the short span of 1.5 hours, but anyway, it's actually a very heavy pleasure for me to explain these things or interact with you people. So if you have any questions, you can ask.
Thank you, sir. Thank you, Dr. Haru. Once again, I thank you for accepting our invitation even in your busy schedule. Extend my heartfelt thanks to you for sharing your deep knowledge and insights on renewable energy. Particularly, you have given a more emphasis on a policy customer demand driving mechanisms and also carbon dioxide removal and decarbonization. Thank you, sir. Thank you so much. I would request Dr. Ravikumar present your views, and also I request the participants also, you can raise your hand, you can unmute, and you can interact with Dr. Janisha Garu. And also you can freely, all participants feel free to post your questions in the chat box, and sir will address your question and answers also.
Any questions from audience side? If you have any queries, please raise your hand. Yes, Nagaraj sir. Please unmute and ask your question, sir.
Good evening, sir. Thank you for
Yeah.
this opportunity. Sir, the lecture was very informative because you have mentioned regarding this green energy decarbonization and the technologies related to green energy conversion. Sir, my doubt is in the aspect of energy efficiency, how can we incorporate photovoltaic in building so that building will be sustainable and free from external grid consumption?
Or mentioning like how we can incorporate PV structures in our household.
Yes, sir.
Yeah. So one of the major concern about in that one is the PV. If you see the efficiency level, it's not that great extent. So you require a larger area for that one. So it's all depend upon how much of uh, space you have for having this PV panels on that one. But now in future, you can even see wind turbines also planted in homes. So now the technology is actually booming in that sense. But PV is almost now saturated, sir. You can easily find one. I'm in Kerala. In Kerala also, we have a lot of subsidies is given by the government as a policy to convert, like I mentioned, distributed power generation system. Nowadays, you can incorporate and you can just connect to the grid. So if it is grid connected, it means you don't need to worry about it. The power will be always available to you. But the problem is like, what is the policy being taken by the state government? Say for example, in Kerala, we won't get price equal price for the power we are generating. But maybe in future, if it is being governed by any centralized agencies, we may expect. It depends upon state to state. In Tamil Nadu, the situation is different. Literally, you will be getting paid for the power you generating. So it's all depends upon the policies, whatever it is actually happening in that particular place, and the roof area you are having available, plus the vegetations also it does this matter for that one, because how much shading you're having, it can also affect the current PV generation also. But it's possible. It's possible. I know places where 100% the surplus energy is being produced and it is fed back to the grid. Whatever they require per month, surplus energy is being produced from solar, and the excess is fed back to the grid. They don't need to pay anything from their pocket for the energy usage. I know places are there near to my home. It is there. It's possible. Did I answer the question?
Yes, sir. Thank you for information. Thank you. No
Yeah.
problem.
Anyone else, sir? Okay. Rajak sir, you please continue for your queries. Please unmute it and ask your questions.
Um, Good evening, sir. Thank you for this opportunity. My question is, Government of India is continuously working on green hydrogen mission 2047. So in that aspect, can you highlight some areas where we can work to get the projects, or areas where we need to specifically concentrate in this particular area, sir?
The current trend is actually happening on electrolysis only. Okay. The current trend, most of the companies are going towards electrolysis, but the most important aspect is the plant itself. Okay, the
Okay, sir.
electrolysis plant itself. So where the green concept, what they're having is like the electricity being, because electrolysis is an energy intensive process. Okay,
Yes, sir. Yes.
anyway, whatever, hydrogen generation is very energy intensive process, but the green concept comes in picture when we try to offset whatever the electricity required for that particular plant is being produced using
Okay.
renewable sources. So
Okay, sir.
you have two opportunities here. One thing is the
Yes.
plant side and process side. If you are interested in process side, you can optimize the process parameters. You can optimize the electrolytes being used. Okay, we
Okay.
do conduct,
Okay.
we do have projects where currently we are doing the same process, like optimizing various electrolytes being used for electrolysis. It is not just water. Water, it will be an alkaline mixture, like usually potassium hydroxide or sodium hydroxide with at
Okay.
different proportions will be added before the electrolysis. You can do that. I mentioned so many softwares, no system modeling softwares, or you can use
Yes.
Aspen if you have access to Aspen. Aspen is a wonderful tool for that one. You can use that
Okay.
one. There are optimization methods available to inbuilt in Aspen, or you can take out the method and you can use any Python API calls for optimizing that. That is one method. The second method is that the matching between the demand and the production. If you are using any green resources, say solar, a mix of solar and
Okay.
solar plus wind, if you are using for this particular process, you
Okay.
you can get a data maybe for wide years of data. You can optimize, you can develop an AI algorithm or ML algorithm for that one. That is the second case, and we have one more case is there. So that the third case, I thought of explaining that one, but it is very different. That's why it is digital twin aspect of that. You can even
Okay, sir.
construct exact replica of your actual plant in digitally, and you can
Okay.
either use MI algorithms or use first principle method or using characteristic curve method, whatever it is. You can make the twins and you can work on the twin and optimize the process parameters. So there are a lot of opportunities are there.
Okay, sir.
Exactly
Thank you
same
very
there is for carbon absorption and carbon
much. Okay.
transmission systems also.
Okay. Okay, sir. Thank you very much, sir.
Thank you.
Dr. Naresh sir, you just ask your questions. Sir. Please unmute and ask.
Yes, sir. Very good evening. Am I audible?
Yeah, audible.
Sir, it was a very highly informative talk, and we got so much information through this talk. Sir, I worked in thermal energy storage using phase change materials during my PhD research.
Okay.
So I developed a product and which already reached the TRL level 4 actually.
Okay.
So what is your suggestion? You mentioned the industry is looking from TRL 4 to 7. So what is your suggestion to
Yeah.
progress in this direction?
Yeah, that's actually a good initiative. I appreciate your initiative and this question.
Yes. Yes.
So the thing about the TRL is no big MNCs will look into TRL 4 to 7. So that's actually
Yes.
because it's actually the value of death. We used to call
Hmm.
it as the value of death. What you can do is you can meet some SMEs, small or
Hmm.
medium scale industries. They are interested in 4 to 7.
Okay. Okay.
There are a lot of industries are there. We may think that nobody interested, but it is there, because they are also looking for technology advancements such that they can also grow to the MNC level.
Okay. Okay.
MNCs will always focus on marketing, how or 7 to 8 years, especially on marketing implementation aspects. They won't take care about 3 to 4. It will happen. They know it will happen. Otherwise, what they will do is they go and will buy one SME and they will make as a part of them. Every industry is doing this. If you
Yes.
see
Yes.
Fevicol, Pidilite, Pidilite is buying most of other companies. Now every components related to the Fevicol kind of things, etc., belongs to
Yes.
Pidilite. Those
Yes.
are some years back. You can go to SMEs. SMEs will be the best one. I also recommend academicians to closely interact with SMEs. Don't hesitate to go and meet them. They may not be, the thing is that they may not be free, because the problem with SMEs is almost all kind of activities will be done by few people, unlike MNCs. You have
Yes.
to go and interact with them.
Okay. Whether they will allow, sir?
They will
As
allow
you told that.
100%. 100% they will allow. Our
Okay.
company, we have some programs inside ISA Bangalore where lot of companies, I'm surprised, lot of small companies are coming up with their own problems, the solution of their problems, what we can do. They are interested. The problem is they don't have that much exposure like MNCs. They don't know where to go, how to go. The same thing we academicians also face. But you
Yes.
can go directly and meet them, no problem at all.
Okay. Actually, my research is about passive cooling of buildings. So I worked for building cooling passively. So I prepared a product, cool roof component. So, but since it is a thermal energy storage material, PCM based, I can also use for other thermal management applications. So, what are your suggestions to further research along with this? Whatever the research I performed so far, I want to also venture into. As you mentioned, so many things are going to be a need of the hour now. Like solar is one of the key areas the
Yes, yes.
government and world is looking at. So, what is your suggestion to work on academic level research so that I can match the requirement of the.
So the temperature range, what we are looking is to what range? It all depends upon that one. The range of temperature, what we are looking. Most of the industry process now it require the PCMs are not applicable there for process,
Yes, yes,
because the temperature range, whatever it is, then it cannot be met using PCMs. But the problem is this will start to disintegrate very fast. PCM.
yes,
The
yes,
biggest problem is a cycling issue.
yes,
You cannot
yes.
cycle the PCMs for too long. So they will be going for molten salt or oil.
Salt hydrates, yes.
Yeah, hydrate systems, so molten salt or in oil, those kind of
Mm.
aspects. But your product may have very good influence on HVAC systems. There you can think about. You can even combine. Now the evolving technology is uh, green refrigerants. If you can implement something in green refrigerant area using the same technology, it will add value to that. But
Okay.
the problem is now the cost of those technologies are too high.
Mm.
Even SMEs also hesitant to bear it, but still there are companies available which utilize these technologies. We also had made a 2-3 CO2 carbon dioxide refrigeration system, especially TCO2 plants, transcutting out plants, where the temperature won't be that much huge. It will be like in the range of 28 to 35 or 40
Okay.
max. That's all.
Okay.
In that range, it will be feasible.
Sir, you may be aware of that. So many other countries are having their own companies which is developing products related to PCMs. In other
Yeah,
countries, especially USA, but in our country,
because of the
very
climatic issue, because
very
of
less
climate,
companies are there. But
because of climate.
applications are so much diverse, right? They can be applied in our climatic zone also.
Any
Even
climatic zone, it is possible.
yes, even PCM clothing, everything is so many things are there. Even electronic cooling can be possible. Battery cooling can be possible.
Yes.
But why it is not being
No,
identified and
battery cooling, we are using PCM, no? We see Aether
yes,
company, they are using PCM for battery cooling.
yeah,
It's
but that is not that much what you call given importance, and so many industries are not looking at this. What is the reason and how we can?
the reason is the replacement.
Okay.
Reason is the replacement and thermal cycling. So that's why I mentioned that we are just you at least went to TRL 4. That's actually
Yes, yes,
great news.
yes.
That level of research, it is not there in PCM. And industry,
Mm,
they are not interested in these kind of activities. They have
mm,
problem, they want to solve the problem. They
mm,
don't want to solve the problem. Maybe something is going to happen at 50 years, after 50 years, or
mm,
5
mm,
years.
mm,
Their
mm,
problems are short term.
mm.
So that's the problem. No, they are not interested in these kind of research. So if we have solid results with us, that's why I told you, just go and meet. Even you can go and meet the other people, or even them also you can go and meet them.
Mm. Okay, okay. So
Yeah,
if we go and meet them, they will show
sure,
interest. You're saying.
100%. The first question they will ask is whether it can, whether it is tested at
Mm,
the level it is using. So where it is
mm,
going to be used, whether you have
mm,
any sufficient data for that one, then
mm,
it is
mm.
fine. That's all.
Okay, sir. Right.
Thank you.
Thank you, sir. Thank you. Thank you.
Thank you.
Thank you so much,
Okay.
sir.
So thank you so much, Dr. Jinsa sir, for your valuable insights. Your presentation was informative and you provided a comprehensive discussion on various renewable energy systems, highlighting the key difference between green energy technologies and renewable energy technologies. The concept of low carbon green hydrogen and carbon neutrality were particularly well explained, offering the valuable perspectives. I'm confident that this session has been highly informative for those working in the field of green energy technologies. We are sincerely hope you will continue to lead more such insightful sessions and share your expertise with us in the future. Thank you so much, sir.
Sure. Thank you, David,
Uh,
for giving an opportunity here
yes, sir.
to at least meet a lot of bright minds.
It's our
Thank you,
honor to invite you, sir. So, sessions are very informative, sir. Most of the participants are also expressed their thoughts. Presentation is well explained, like that they mentioned in the chat box also. So, I hope
Yeah,
everyone
sure.
is enjoyed with this presentation. Thank you, sir.
Sure. Thank you. Shall I drop off?
Yes, sir. Okay, you can leave the sessions.
Thank you.
Thank you. So, good evening, audience. The session 2 will be handled by Dr. M. Senthil Kumar Garu, Professor from NITTR, Chennai. So, I request Subramanian sir to uh, talk to Senthil Kumar sir.
Welcome, sir. Senthil Kumar Garu.
Yes, sir. Yes, sir. Good evening, sir. Okay, participants. Good evening to
thank
all.
you.
First of all, I thanks to the organizer, Dr. Sivasubramanian sir, and also for Ravi Kumar and other organizers, and given the opportunity to discuss that is advancements in solar PV systems for the benefit of the participants. Sir. Okay, sir. Please. Okay, sir. Can you start?
Yes, sir. Yes, sir. Thank you.
Yes, sir.
Yes, sir. 1 minute, sir. I have to share my screen, sir.
Yes, please, sir.
Already one screen is there. Stop the screen. Stop the already one screen is presented
Yes,
here.
sir. Also.
Please stop. Yes, sir. Okay. Is it visible, sir? Screen is visible?
Yes, sir. Yes, sir.
Is it audible?
You please
Okay.
go ahead, sir.
Okay. Good evening to the participants. All we are assembling for the ATAL program of this green energy storage. There is innovative methods. And that is basically, first of all, introduce myself. That is, I'm basically a B mechanical engineer and master's in energy engineering and PhD in solar energy from National Institute of Technology. And Ravi Kumar also, that is, did PhD along with me. And in this session, now we have to discuss about the advancements in solar PV systems and application. In our NITTR, we are conducting a mini program. I also conducted more than 200 training programs in the areas of solar energy. In this, normally in our training programs, we have to content, that is a teacher, how that is first one, content updating, as well as how to teach and what to teach. These are the things normally nowadays the teacher is a facilitator. Nowadays, different type of learners are there, diploma level and bachelor level, master level, and research level. Different type of learners are there. Nowadays, a lot of opportunities, a lot of advancements for the learning. It is internet and other things. Those period only the books and also the teacher only discuss the thing with the participant. Nowadays, a lot of opportunities to learn that is in the internet, as well as for a lot of discussions, conferences, and training. In this way, nowadays the teacher is a facilitator. We have to facilitate to teaching and learning as well as for the research. In this way, our training is somewhat different compared to there is other training. In our NITTR, more than 20 years, I conducted there is a lot of training programs. In that way, I am also discussing this topic with you from the basic to the advanced level. Because different type of learners are here. There is a diploma level, bachelor level, master level, and research level are there. So we have to satisfy all the levels of people. We have to start from the basic to the advanced level. That is in this one, solar PV is not only the separate one, that is including the solar thermal. Nowadays, the solar energy is available abundantly, and we have to utilize proper, that is devices we have to invent, and we have to capture the energy for the utilization people. Nowadays, the engineer's duty, that is we have to design, manufacturing, and maintenance of the energy devices. That energy devices, they have to capture the energy of solar, and it will be useful for the public utilization. There is a major, that is a duty of our engineers nowadays, technocrats and engineers. Okay, sir, we have to start from the basic of the thing of energy. All the people, we know the concept of the energy one, capacity to the one. That is a basic conventional, non-conventional, renewable energy sources and non-renewable energy sources. And also for, that is a fossil fuels. Nowadays, the fossil fuels, it is available up to the certain period. Nowadays, all the people, we have to concentrate the renewable one. Nowadays, a lot of, that is power production, majority of power production from the thermal power. So gradually we have to replace the thermal power plant. Thermal power plant, there is a coal-based thermal power plants are there. So we have to gradually replace the thermal power plant with alternate sources. That is a renewable energy sources in different way, in this form of the solar, wind, as well as for biomass and hydrogen, and also for compressed natural gas, using the different type of nowadays a fuel cell. These are the different type of renewable energy sources we have to, that is a replace that is existing thermal power plant and other things. And there is different forms of the energy one. Nowadays, the chemical energy, due to the, nowadays we have to the battery storage. That is based on the reactions we have to store. There is a wet battery and dry battery and nuclear energy. Our solar energy is also there. There is a nuclear, there is a fusion reaction only. That is we are getting as a solar energy. And also for nuclear, there is a nuclear fission reactions and mechanical energy, internal energy in the body. Now there is a combustion of the food, bioenergy in the plants, and thermal energy, heat energy, different forms of the energy one. And stages of the energy one. That is a final usable energy form is our utilization. Nowadays, now we are using this, that is a laptop and the different appliances. Everything is based on the electrical energy one. So the electrical energy, wherever the resources available, we have to tap and we have to convert it into the usable form. That is the thing. And law of energy conservation, all the people we know the concept of there is energy can be neither created nor destroyed. It will transform one form to the another one. And the energy science and energy link in the form of the solar energy, we are also telling sun also emitting the energy in the form of the light as well as the heat one. And suppose we are considering for steam generation, that is a steam thermal energy turbine, it is converted into mechanical energy, and finally we are getting as a electrical energy due to the generator. So these are the energy chains and links. Another one, it is a main concept, that is a energy science, energy technology, and energy engineers. Nowadays a lot of energy engineers available, energy technocrats, energy scientists. What is the role? That is a normal concept of the science means study anything, it will be studied in a systematic way and procedural way, scientific principles, laws, rules, etc., various forms of energy and energy. There's the energy scientists, they have to develop the concept, and they have to develop some prototype model, not a major one. How is the technology means the application part of the energy science for work and process. What is the role of energy engineers? Nowadays, a lot of energy engineers, there is a different engineers. There is a role of the engineer mean, there is a energy science is a basic concept, technology is a user area. What is the role of engineers? We have to design some simple concept. We are also having a cell phone or otherwise cell phone. That is a basic concept in that one, current flow, zero, not flow. There is a digital electronics inside. Final user end. Now we have to use for that is a different communication under the internet browsing. That is a in between. There is engineers only they have to design. Similarly, for the solar, different type of equipments needed. Solar energy is available abundantly. User also need the energy needs. So that is engineers, we have to concentrate in that way. That is the first one. That is a lot of researchers they have to do. That is a that is a theoretical as well as analytical and experimental way. They have to develop a device. Majority of that that is a research. That is the people are doing some software, that is a simulation, and finally submit the paper and publish that get the degree is not a good one. That is simulation. That is a software tool is only for assisting your innovation things. That is the thing. So you have to develop your innovative idea. What is the final? What type of device you have to design, and it will be useful for the society. That is nowadays the innovative ideas in green energy technology, and also for that is storage things. So final concept, your aim, it should be we have to develop a device. The device should be convert the energy and useful way, and we have to use a lot of softwares. Softwares used for optimization and for simulation and other things. Many researchers I have seen in my life, my age is around 52. Lot of researchers they have to develop. They're taken some lot of literature survey and also do and certain simulations and software. Finally submit the that is a thesis publishing paper. It is not a good. That is a energy engineers. You have to develop a device. That is a software. You have to optimize the things and simulation. There is an initial way. Final aim. There is you have to invent the device. It is anything. There is a in this ATAL program. Lot of researchers are there. I have to give that idea. There is a information too. That is a final your PhD thesis. You have to develop a device. That is a developed one. There is a final one. Design, manufacturing, and maintenance. Software tools are helping your research. That is the thing. Okay. There is energy science, energy technology, and energy engineering. So nowadays the energy, the man and environment. There is environment. Nowadays there is a different type of energy transformations. Nowadays solar energy, wind energy, bioenergy, different solar, our photovoltaic and thermal energy things. So that is a man is a major, that is an active element in the environment. You have to utilize the proper way. In this way, there is a sustainable energy. We do not pollute the environment. That is a major thing. There is a eco-friendly devices you have to invent. There is a conventional and non-conventional energy sources. There is a conventional, non-conventional fossil fuels. There is a coal and petroleum derivatives. These are the things we already know. Different type of renewable, solar energy, wind energy, bioenergy, tidal energy. Nowadays, different type of there is uptide and downtide. There is we have to construct a tidal basin. We are getting tidal energy, geothermal. That is that is a center part of the earth is a molten core. So that is nearby that water will be converted into steam as well. Otherwise, the rock is a hot rocks. So we have to send the water that is will be converted in steam. It will be useful for the power generation. And ocean thermal energy conversion. That is a temperature difference between the surface of that sea and inside of the sea is somewhat different. We are using some that is a fluid. We have to pumping the system. We are getting as a energy. These are some basic concepts. In our Tamil Nadu, they are having a some idea in the southern part of Tamil Nadu, Kulasegarapattinam, they are also decided one place they have to construct a ocean thermal energy conversion here. And come to our solar part, that is solar energy, how much amount that is a uses, what type of uses can be possible in the solar energy? Water and space heating, desalination. Nowadays, that is a sea water, it will be converted into potable water with the help of the desalination, drying, refrigeration, power generation, distillation, photovoltaic system. Wind energy, water pumping, milling, grinding, pressing, power generation, and small industry work. These are something that is a biogas, cooking, power generation, heating, lighting, and small industry. That is improved wood stoves. That is improved chulas. That is for the rural development. There is a government also given for that one to avoid the deforestation. There is a small hydropower, power generation for cooking, heating, irrigation, lighting, checks, deforestation, ocean thermal and tidal power mainly used for power generation. Now come to there is a world electricity production nowadays, 28,844 terawatt hour. That is nowadays there is a more than 70% is the fossil fuel and nuclear. Renewable energy contribution, that is electricity's contribution is 30%. So it should be increased nowadays because coal is available. That is in different places. Now we have to operate the thermal power plant. And that is one time it will not be available. So there is a renewable, we have to concentrate, particularly in the solar energy is available abundantly. We have to use the world electricity production, 28,844 terawatt hour. That is an Indian energy scenario. In India, how much? That is the Indian National Electric Grid has an installed capacity of, that is a 442 gigawatt as of 31st March 2024. That is renewable energy plants, which also include the large hydroelectric power plant. That is we are including the hydroelectric. That is plants constitute 43% of the total installed capacity. Suppose we are not considering the large hydroelectric, only we are considering a small hydroelectric power plant, means around for 25%. That is the thing. There is an Indian renewable energy up to that level. That is an installed capacity in India as on 31st October 2024. That is a there is 156,247 megawatt as on 31st October 2024. That is nowadays the major contribution is the wind energy, 54%. Our solar energy, solar power, that is a 25%, and also for biopower 14%, small hydropower 7%. So next to the wind energy, solar power contribution is the major one. Nowadays the government also given a different type of subsidies, that is for the rooftop solar power plant. That is a solar power 25, it should be increased in further years. That is as on 31st, that is October 2024, that is a solar power cumulative. That is a 92.12 gigawatt, ground-mounted solar plant 71.05 gigawatt, grid-connected solar rooftop 14.45 gigawatt, hybrid project, that is a solar component, that is a 2.63 gigawatt, off-grid solar 3.99 gigawatt. This is the as on 31st October 2022. That is a solar power, that is a 92.12 gigawatt is installed capacity here. There is a majority of that renewable energy sources. There is our solar energy, wind energy, and bioenergy. These are the technology transfer. First of all, I told there is every technology, it should be useful for the society. Whatever the devices we have to invent, it will also convert that is a primary source to the final use. There is similarly for the solar energy, wind energy, and bioenergy. These are the fully converted into, that is a technology transfer. First one, solar energy, I already told that nuclear fusion reaction. That is nowadays the nuclear reactors are based on the nuclear fission reactions. But in the sun, that is due to the nuclear fusion reaction of combining hydrogen atom to form a helium atom. During that time, enormous amount of the heat is released one. So in the solar energy, there is a sun emitting, that is liberated in the form of the light as well as the heat. Light mainly used for electrical power generation, heat is used for thermal applications. Energy is radiated by the sun as electromagnetic waves. This is the science of the solar energy and sun. And some of the data, that is the sun diameter is 1.39 in 10 power 6 kilometer. Earth diameter is 1.27 10 power 4 kilometer. Distance between sun and earth is 1.5 in 10 power 8 kilometer. The estimated power released by the sun is of the order of 3.8 10 power 26 watt. The earth intercepts only the 1.78 into 10 power 17 watt. So large amount of energy is released one. But user needed a lot of energy. That is a energy demand. So engineers in Tamil Nadu, a lot of engineers, lot of engineering colleges, they are producing a lot of engineers. In throughout India, a lot of engineers. There is every year, lot of engineers are coming. So all the engineers, you have to concentrate in this one to that is a design and develop the devices. There is a lot of solar energy is available. You have to there is a capture the solar energy and it will convert into useful form. Another one, sun is the mother of all the energy sources. Nowadays, different people are telling wind energy is separate, bioenergy. No. That is, we are in the solar system. Sun is the central one. All the planets are there. In the Earth is one among the planets. So, sun, our fossil fuels also based on the photosynthesis by the ancient plants and algae. There's a petroleum, natural gas, coal and wheat. There is a fossil fuel. And renewable energy. That is a direct use of solar energy. We have to use that is in the form of the thermal as well as for that is electrical energy. Differential heating of atmosphere, wind and hydroelectric power, heating of ground source heat pump, photosynthesis by modern plants and algae, the wood, charcoal, other plant that is a plant parts, ingestion by animals, the manure, liquid biofuels, and nuclear reactions, natural and engineered. There is a non-solar related energy, nuclear fission, nuclear fusion in the earth, and geothermal, gravitational pull of moon. There is a tidal energy. So sun is the mother of all the energy sources. Some of the there is a people, there is a solar constant and solar radiation. That is the amount of energy received in unit time on unit area perpendicular to the sun's direction at the mean distance if the earth from the sun one. Standard value for the solar constant, that is 1353 watt per square meter. But solar radiation may be maximum value of 2000 because it is in the elliptical, that is a path. That is due to the variation between the sun and the earth due to the elliptical motion of the earth one. The solar radiation, this is a spectral distribution of solar radiation intensity. The x-axis is the wavelength and y is that solar, that is a beam radiation, watt per meter square and micrometer. That is the thing. Here, that is solar radiation, 8% of ultraviolet radiation, short wavelength less than 0.39 micrometer, 46% visible light, 0.39 to 0.78 micrometer, 46% infrared radiation, long wavelength more than 0.78 micrometer. And this is that wavelength, that is a graph between the wavelength and also that is a spectral beam radiation one. There is a spectral distribution, and that is a curve will be increased and maximum go for the 2000 around, and it is a it will be decreasing. And the next we come for the solar radiation and types. That is in sun already told, there is a sun is emitting the radiation in the form of that light as well as the heat one, and is in the electromagnetic waves. So the direct radiation and diffuse radiation and global radiation, that is called as a total radiation. So in this one, directly the radiation come from the sun, that is the sun to the universe, that is and also it will hit the planet. Suppose we are considering the planet is the surface of the, that is the earth one. Direct radiation and diffuse radiation or scattered radiation, some of the particles present in that one, it will be scattered or diffused radiation. So that is a simple example I am telling. Suppose all the people were also, that is going in the bus. The bus also having a, that is a glass doors and some of the openings are there. So that is sometimes there is solar radiation is coming. There is a vehicle is moving. So the air also come and hit your body and moving. Suppose any place, it will be due to the traffic at the signal, it will be stopped. So at the time, there is solar radiation is directly, there is a coming one. At the time, that is we have to feel, that is we have to feel as an inconvenience due to the sweating and other thing. So that is the concept, that is a direct radiation is coming inside through the transparent material, and also due to the diffuse radiation inside scattered, there is a diffuse radiation, it will make as an inconvenient. There is a more warm inside one. That is the concept of diffuse radiation. So it is an inconvenient for us, but it is a convenient for solar power gadgets and solar thermal applications. That is normally the solar thermal application, they are having the 2 layers of glass covers for the purpose of to also admitting the direct radiation, and that is increasing that more amount of diffuse radiation inside. That is a more warm environment inside between the glass cover and also the devices. So the measurement of solar radiation, the global radiation is measured by the pyranometer. Direct radiation, the beam radiation is measured by the pyrheliometer. These are the devices. And some of the solar radiation data in India. India is situated north of the equator, but in the 8 degree 4 minutes north to 37 degree and 6 minutes north latitude, and 68 degree and 7 minutes east to 97 degree 25 minutes east longitude. So 4 to 7 kilowatt hour per square meter per day. India has the area of 32, that is 32 lakhs and 87,263 square kilometer. Normally, the 300 sunny days available in major places, we have to install a solar power gadgets in different places, and different type of applications we have to see in that one. First one, solar water heating, solar space heating, solar space cooling, solar thermal electric conversion, and solar electric power generation, solar pumping, solar furnace, solar cookers, solar distillation, and solar greenhouses. These are the things we have to see one by one. First one, the solar water heating. That is mainly the flat plate collectors as well as the parabolic collectors. That is a focusing type. Normally we are using. In this one, it is a cut section of the flat plate collector. There is a cut section of the pipe. All the pipes will be brazed, and that is in the bottom head and top head they have to arrange. And water will be initially filled to that one. That is due to the direct, that is solar radiation, due to the transparent place, it will become inside. And due to the diffuse radiation, more, that is a warm environment in between that absorbing surface to the solar radiation. And this is the solar water heater using the flat plate collector. This is the solar radiation. So in this storage tank, initially all that it is in the cold water, that is a room temperature. And initially due to the solar radiation, that is due to the density difference in the solar water in the solar flat plate collector, it will moving upward direction and will be initially stored in the top due to the density difference, initially 5%. That is due to the natural, that is called as a thermosiphon method, and also the forced circulation methods also there. Due to that one, that is initially the 5%, after 10% and 15. So due to that 5 to 6 hours, we are getting as a, that is a warm water, maximum for 80 degrees possible here. That is a solar water heater using the flat plate collector. And that is in our institute, that is we only had that solar water heater 300 liters per day. That is they are also having the pipes, and also the plates will be brazed and block coated. And also for solar thermal training system in our institute, in the solar thermal training system, that is a different type of experiments we have to conduct with the help of, that is initially the cold water and hot water tanks are there. That is we have to natural circulation method and also the forced circulation method. We have to conduct a different type of experiments, and that is initially we have to use for the water, and that is some of the researchers they have to use for the nanofluid. And for that solar thermal training system, that is I have to share that visual of that solar thermal training system. That is in our institute. 1 minute. One minute, sir. I'm sharing this visual. There is two types of training systems available. One is the photovoltaic training system. Another one is the solar flat plate collector thermal training system. In this training system, we are also capable to find out how much amount of, that is overall heat transfer coefficient of the flat plate collector, as well as the flow, how much amount of water flow, and inlet water temperature, as well as for the outlet temperature, collector pressure, inlet pressure, and also for the outlet pressure, how much amount of the plate getting the heat from a temperature, that is called as a plate temperature. Everything we are getting in this control panel. This system capable to conduct the experiment in open mode, that is in a direct sunlight, as well as for a artificial sunlight, artificial source. In the artificial source, we are also having halogen light. We have to discuss the thing in the next one. Suppose we are considering, first we have to conduct the experiment in the open mode, that is in natural sunlight. Here we are also having a two cold water tank. One is here at the top, another one is the bottom. So that is the top, that is the bottom cold water tank is initially we have to fill the water. Then it will go to the flat plate collector, and also the flat plate collector, after the heating, it will come to the hot water tank. It is the main concept. There is a flat plate collector is fitted in the, everything is fitted in the movable structure. So we can transfer that whole thing to the open mode, and also we have to come inside the laboratory to the artificial source of the halogen lights. So in this, it is a main control panel. We are also getting all the parameters. One of the main parameters is the pressure, another one is the water,
water temperature, as well as for the plate temperature, flow meter, and wind speed and radiation. So these are the things we are also getting. But first we have to get the temperature. This is the inlet water temperature. We are getting a, suppose water will come from this cold water tank to the, that's a flat plate collector, is inlet water temperature. Another one is the second one is that after the collector, it will also come, we are getting as a outlet water temperature. Next one, suppose it is a thermosipon mode. That is a temperature pressure is not as a important one. So suppose it is a forced mode. At the time we have to measure the pressure also. That is the inlet water pressure before enter the collector, and also for the that is outlet water pressure. How much amount of the pressure we are getting after the heating of the water. So in the thermosipon mode, they are also having a, due to the density difference, it is also going in the upward direction. But in the flow meter, we are also giving a power supply to move from a bottom to the top in the flat plate collector. And also the plate temperature, everything we are getting this panel through the thermocouples. Different sensors are fitted in the flat plate collector, we are getting. So there is a hot water is stored in this one. The hot water is nothing but it's inside, it is a stainless steel plate. After that, they are also having a rock wool, that is a insulation system. Outer is the aluminium cover, it is a block coated. So it is arrangement of the hot water tank, cold water tank, as well as for the, this is the control panel of the everything. It is and also having a different pipelines having, different wall we are also having, how we have to conduct the experiments. Suppose in the experiments, suppose in this normal thermosipon mode, all will be taken to the outside, you will be directly go to the sun radiation condition. In this solar thermal training system, flat plate collector is the main component of this total arrangement of this training system. In this flat plate collector, they are having a different, that is a vertical pipes. All the vertical pipes is connected by the, that is a top header and bottom header. That is a bottom pipeline. So that is already I told, the cold water tank is coming from the top, it will come through this line. And come through this line, enter to the, that is the bottom pipeline of this flat plate collector, through the flow sensor and also for the inlet water temperature sensor one. I already told everything is we have to see in the control panel in the back side of this training system. So the water will be entered here. The initial system, all the water is coming from this cold water is fully present in all the pipes of this flat plate collector. The flat plate collector pipes are a block coated and also having a, this type of the plates are brazed. These are also a block coated. So the black body is a perfect absorber. So that is, it will also open to the sun radiation. So it will absorb the radiation one. In this solar power meter, we have to measure how much amount of the solar power we are getting through a particular square meter. Mainly used for watt per meter square one. That is a watt per square meter. So it is using this one, that is a sun radiation. We have to show this solar power meter, that is a particular this one, and also based on the sun one. There is a sun radiation, it will fall on the particular ball arrangement. So based on the sensor arrangement, we are also getting as a how much amount of the, that is a solar power we are getting, that is a natural source, watt per meter square. Another, we are also having a facility, that is a BTU, that is a British thermal unit. So they are also having both the facilities available in this system. So this is another one important instrument device. It is mainly used for measure how much amount of the solar and how much amount of the solar is used to convert the cold water into the hot water. Suppose the cold water having the temperature around the atmospheric temperature. Atmospheric temperature is around for, it may be 29 or 30 degrees. Suppose we are getting the temperature initially for 45 degrees. We are also having an outlet pressure sensor and also for an outlet, that is a water temperature. Initial temperature is 30 degrees from this pipeline. So due to the thermosipon, in this thermosipon arrangement, due to the density difference of the water, that is a gradually, that is a hot water is moving in the upward direction and it will be stored in the hot water system. That is a magnetic dial. Based on that, we have to fix in the, that is a frame of this one. This flat plate collector, we are having the facility, it will also tilt the different tilt angle and also for the incident angle. And based on the sun orientation, based on this facility, we have to tilt and we have to conduct in the different situation, different flow meter, different angle, different incident. And same experiment, we have to conduct in the natural mode as well as in the artificial mode. Suppose we are also getting how much amount of the solar energy used for heating as well as for the light generation. Suppose the power generation, we are also having a separate equipment, that is a solar photovoltaic training system. That is in this training system, we are also conduct the experiment in the natural, that is a mode of the sun radiation. Suppose we want to conduct the same experiment in this inside the laboratory Otherwise, sometimes the sun radiation is not in a proper way. Some of the cloudy seasons. At the time, we have to conduct the experiment with the help of the natural artificial source. In this one, we are also having a halogen lamps. So all the halogen lamps are fitted in this one, and also having a reflecting mirrors there. So using this one, we are also getting as a, that is a power as like as a sun one. In this one, we have to conduct the experiment with a different radiation level. So we are considering it is a radiation one. So it is used to measure the radiation power. So that is halogen lamps emitting the lighting, and also we have to measure the radiation, how much amount of the radiation is coming from this artificial source. Suppose the same will be used to conduct the experiments using this artificial source of the lighting system. We are also conduct the experiment using this radiation meter. We have to measure how much amount of the power we are getting from this radiation arrangement. So we are also taking the reading in a different 4 or 5 places. Here is one place, second place, third place, fourth, and 5. So we have to get as the average of the all the 5 or 6 readings we are getting as a radiation. So using this one, we have to change using this valve arrangement. We are sending the water and also the flow. Using the panel control, we are controlling the flow meter. So that is a water. Suppose we want to conduct for different, that is a wind speed mean, we are also having a fan arrangement here. So using this one, using this fan, we have to vary the, that is a wind from bottom to the top one. Suppose in this one, we are also having a anemometer. In the anemometer, we have to measure how much amount of the wind speed is flowing, passing around this flat plate collector. So all the parameters we have to collect. Using these parameters, using the panels and also the different sensors and other things, we have to find out the flat plate collector is capable to different situations. Suppose in the thermosifon mode and also forced mode. So, and also for the different, that is a flow, that is using the flow meter and different wind speed, and also for the different radiation level, we have to find out the how much amount of the heat we are getting this flat plate collector. That is a one. So using this training system, the students also capable to understand what are the functions and also the principle of the flat plate collector, how we have to use the sun radiation, that is a natural source, and how we have to use the artificial source, and also we have to find out the performance of the total flat plate collector, and also we have to find out the efficiency of the one, because efficiency is the important one for all the equipment. Here we have to find out the efficiency of the flat plate collector, particularly is a solar thermal flat plate collector system. So I think you have got a exposure on this total training system as well as a flat plate collector.
Normally in our regular training program, we are also demonstration this type of flat plate training system and conduct some experiments. And these are the participants from university and otherwise, and also for the polytechnic teacher. So in our regular training, there's a theory as well as practical we have to conduct. Okay, sir, return back to our presentation. Because normal in our training methodology, continuous lecture is not as a attentive one. So different type of that is a different type of methodology used for the training. There's a demonstration, lecture, as well as in the regular training means you have to go for the discussion and tutorial and other thing. So it is a thing, and I'm also sharing the visual. Next, there is a focusing type collectors. The focusing type collectors normally that is a parabolic, that is a dish as well as there is a parabolic trough they are using. Normally in our school days, we are using the concentrating lens. We have to focus the solar radiation to the particular point to burn the cotton or there is a paper. Similar concept, the parabolic reflector, all that radiation it will be focused to the particular point. There is a particular point with the help of the reflectors. So higher temperature is possible. Similarly, if it is a point focusing and line focusing. In the line focusing, that is having there is a particular, there is a tube is there. So there's a parabolic trough that is based on the sun position. It will be that is it will be that is a tracking the system is there. There is a natural, there is a mechanical tracking, otherwise electrical tracking, as otherwise photo sensor based trackings are there. There is a focusing type collectors, and this is a parabolic dish as well as for parabolic trough, and mainly that is used for the steam generation by solar concentrating collector. Visuals related to that one. Is a parabolic trough collector. As the steam generation is possible. Okay, sir, return back to our presentation. One minute. Nowadays, the solar water heating using the nanofluids. Nowadays, that people are using the nanofluid and nanoparticles. There is a mostly used nanoparticles: silicon dioxide, multi-walled carbon nanotubes, aluminum oxide, titanium oxide, magnesium oxide, copper oxide, copper, carbon nanotubes, silicon carbide, zinc oxide, ferrous oxide. They are having a nanoparticle. They have to mix. That is a make as a nanofluid used in flat plate collector, evacuator tube, direct absorber, parabolic trough, solar dish, thermal photovoltaic. These are the some. There is a due to that one. There is a more amount of that is heat is absorbed. It will be used for that is but it is a major problem that nano fluid directly using means that is a mixed with water. It is not passed. It is a potable one. They are having a separate heat exchanger. There is a primary circuit and secondary circuit here. In the primary circuit using the nano fluid, that is they are having a heat exchanger, non-mixing type heat exchanger is used to exchange the heat to the water. That is the arrangement is needed for that one. Another one that is some of the journal referred, that is a solar water heating using nanofluids, a comprehensive overview on environmental impact analysis. There is a Arun Kumar Diwari et al. They are also using the aluminum oxide efficiency improvement in flat plate collectors improved from 52.4% to 61.6% with a concentration on 2%. So using this nanofluid, that is a more amount of that is efficiency is improved one. It is published in the International Journal of Emerging Technology and Advanced Engineering. Next one is solar space heating. There's a passive heating and active heating system. Suppose it is a passive heating system. Nowadays, the concept, nowadays, all we are discussing about the green building, there is a green energy. There is another one concept, it's the green building or that is a energy efficient building. So, energy efficient building or green building concept mean we have to utilize the natural source. That is a sunlight as well as the air. We are utilizing the naturally. We have to avoid the, that is a other source of, that is a air conditioner, blower and other thing. And that is to avoid the lighting as well as we are used to make us a warm or otherwise cold. We have to, that is a naturally we have to utilize the solar energy. So first one we are considering a passive solar heating system. In the passive solar heating system, suppose a particular wall, it is a wall is there. The wall we want to make us a warm air inside. It's suppose a particular place in the cold climatic region. So we have to make us a 4 or 3 holes in the bottom and the 4 or 5 holes in the top. And that is we have to place 2 layers of glass covers, that is a 10 to 20 centimeter outside. Then it is a block, that is a blackened surface. So due to that solar radiation, direct radiation is coming inside and hit the black surface and also diffuse radiation to make us a warm environment in between the wall and also the glass covers. There's a cold air going and enter the particular place. That is because due to the density difference, automatically that is hot air moving upward direction, it is come to the air. After a certain period, it will be making as a warm air inside. There is a passive solar heating system. So the room storage of solar heat. So that suppose it is a single story building, we want to make us a that is a make us a warm air inside after the sunset. So there is a movable panels. First we have to construct a metal roof. Above the metal roof, we have to place the water bags. And nowadays there is a PCM bags are used, and also the movable panels. Due to the solar radiation, it absorbs the heat, and the heat is transmitted to the metal roof, and it will be transmitted to inside. There's a roof storage of solar heat with a passive system and the active system. Suppose it is a multi-story building, we want to make as a warm air inside. At the time, we have to take them through the pump, and it will come to the water tank storage unit. It is nothing but it is a non-mixing type heat exchanger. The primary circuit flood plate collector. It is a hot water is here, and also here also that cold air coming and receive that that is a heat, and the hot air circulated to inside the building. It is that water that is an active system. Suppose some of the researchers, they are using the nanoparticles and fluids used for space heating. Some of the researchers, QK et al. In the year of 2019, they are review of high temperature selective absorbing coating for solar thermal application. They mentioned in the Journal of Metromics that is aluminum oxide and ferrous oxide nanoparticles used in block coating to absorb more amount of heat. That is a block coated, they are using the nanoparticles. Nanofluids used based on the nanoparticles for the heat storage. That is the thing. Another one, space cooling. That is a vapor compression refrigeration system using the solar energy. There is a vapor compression. There is a primary circuit and secondary circuit. The primary circuit, there is a concentrating collector. There is a parabolic concentrator. Due to that low boiling fluid, there is a boiler is there. So due to that solar radiation, that is it will be converted in vapor form. It will be expanded in the turbine and cooled in the condenser, and again return back to the boiler. It is a primary circuit. In the secondary circuit, in the vapor compression refrigeration system, normally that is we are using the electrical motors. That is instead of electrical motor, this turbine and compressor arrangement, we have to get as a rotary motion. It is a vapor compression refrigeration system using the solar energy. Vapor absorption refrigeration system using the solar energy. Normally that vapor absorption, ammonia, that is a refrigerant is used one. Here, that is instead of that compressor, normally use the absorber and generators in the vapor absorption refrigeration system. In that, suppose after coming from the refrigerant, coming from the evaporator in the absorber mixed with water, and it go to the generator, it is normally the electrical coils are used to heat and separate the ammonia vapor and also the water. But here they are using the solar collector, they are using the heating coils. It's a solar absorption refrigeration system. Another one, nano refrigerants. There is single-walled carbon nanotubes. There is a R407C nano refrigerant used, suppose using means cooling load, compressor work, and COP for different cases. That is that's S. Ragaman et al. In the year of 2019, researcher team, the performance enhancement of solar-powered air conditioning system using the passive techniques and single-walled carbon nanotube. There is R407C nano refrigerants. That is case studies in thermal engineering journal. They suppose the cooling load is the same one. That is 1078, the conventional system with nano refrigerant. This is a solar powered air conditioning system. That is 1078, and work input that is 309.086. But there is a system using the nano refrigerant. It is they have got from that findings. There is a 296.72 and coefficient of performance 3.48 in the conventional system using the solar power air conditioning using that carbon that is carbon that is a single wall carbon nanotube R407 nano refrigerant. That is a COP is a 3.63. Next one is a solar thermal electric conversion system. In the solar thermal electric conversion system, 1 minute. First one, that is a solar thermal energy conversion system. They are having the primary circuit and secondary circuit. The primary circuit, normally they have to use the low boiling fluid like there's a butane in the liquid form. In this primary circuit, solar, that is collectors. In this water circuit, 1 minute. In the water circuit, that is there also, it is a low boiling fluid, it will be heated and it will be expanded in the turbine. It is, we are connected to that generator, we are getting electricity. Again, it will be cooled and returned back to the boiler. It is a primary circuit and secondary circuit. Next one is a solar electric, that is a power generation. That is a solar photovoltaic systems. So it is a direct conversion system. So direct conversion into electricity. So that is they are also having a N-P type, that is a silicon, that is a pairs are there due to the solar radiation. That is a photons. Normally that energy is liberated, that is a light as well as the heat, light in the form of the photons. That is already the biological plants using this photon, that is used for photosynthesis process. Using this photosynthesis process, they have to produce the biomass. It will be stored in the leaves and the stem and also for roots of that biological plant. Similarly, the same concept used here, that is due to that photon energy, that is it will be disintegrated, that is a disintegrate into, there is a P and N type silicon. N type, there is a negatively charged electron. It will passing through the load and it will be can go and fill the positive holes inside. So there is a concept, there is a flow of electron is called as electricity, but that is a single cell having the concept of only for 0.5 volt. So they have to arrange in series and parallel manner. We have to get as a record output. That is normally the photovoltaic material, silicon solar cells, the monocrystalline, polycrystalline, thin film solar cells, cadmium telluride, and copper indium disilane. These are the materials used. And photovoltaic cell, module, and array. Each cell, combination of cell is a module or PV panel. Combination of module or PV, that is a panel, is the array. And combination, it is called as a power plant. There is a photovoltaic power plant. And that is each, suppose we are considering a silicon, that is a silicon cell. That is a silicon PV cell. They are the layers. They are having an aluminum frame top. There is a tempered glass, an encapsulant, that is EVA, and solar cells, an encapsulant, that is a ethyl acetate, and is EVA, and backseat and junction. It is a normal. These are the components available in our solar PV cell. And we have to see that solar cell, there is a PV panel manufacturing through the visuals.
Suntech is the world's largest manufacturer of crystalline silicon cells and modules. Here in our facility in Wuxi, we do both the solar cell manufacturing and also module fabrication. This film is to give you an overview and introduction to both our solar cell and module fabrication facilities. Suntech's commitment to excellence starts with its employees. We provide a safe and healthy work environment for our entire staff. Cell production begins with Suntech's patented texturing process. An etching solution forms pyramid-like structures on the surface of the monocrystalline silicon wafer, reducing reflectivity from over 30% to around 11%. Next, the wafers are cleaned thoroughly and placed in a diffusion furnace. Phosphorus source is fed into the furnace via a carrier gas. The generated phosphorus diffusing into the wafer surface at a high temperature, forming a PN junction. Next, unwanted phosphorus diffusion is chemically removed from the edges and rear surface in another patented process. This unique process ensures the solar cells have excellent shunt resistances and higher efficiencies under low light illumination. In the plasma-enhanced chemical vapor deposition area, the wafers are placed in a furnace and coated with a silicon nitride anti-reflective coating. This coating further reduces reflectivity to 6%, which, combined with the texturing process, reduces the overall surface reflection to around 1% at special spectral range. aluminum paste is applied to the wafer's rear surface, further enhancing cell efficiency, while silver paste is screen printed onto the wafer's front and rear surface, and then co-fired, act as the cell negative and positive to metal electrode. The cells then undergo rigorous testing and sorting using a solar simulator. Quality controls performed at every step of the production process, from receiving the incoming wafers to packaging. The completed cells are sent to our solar module facility to be assembled. First, solar cells with the same characteristics are soldered in series. The interconnected cells are placed in a sandwich structure comprising a front sheet of tempered low-iron glass, a layer of EVA, the solar cells, another layer of EVA, and a back sheet. This sandwich structure is laminated to protect the solar cell from moisture and mechanical shock. The laminated cells undergo a
1 minute, sir. 1 minute, sir. 1 minute. One thing I think that sharing is missing one way.
Use a robot to ensure accurate movement.
One minute, 77. Okay.
And beyond the strictest international standards. Cooperation with UL, TUV, VDE, IEC, and China's CGC, we are able to perform testing meeting or exceeding IEC standards. The modules are packed in our customized packaging and sent to the warehouse. From start to finish, our production process epitomizes the reason for our remarkable success. An extraordinary commitment to providing a top quality, good value product.
Okay, sir. I return back to our presentation.
Sorry to interrupt you, sir.
Is it audible?
Yes, sir. Sir, sorry to interrupt you. Sir, we have only 15 minutes of time, so can you
15
complete?
minutes. Okay. Is it audible?
Yeah, it is audible, sir. Okay, thank you.
15 minutes. Okay. And there is a large level, it is a photovoltaic power plant. And applications of photovoltaic systems, radio beacons for ship navigation at ports, water pumping sets for micro irrigation and drinking water supply, power supply for house, street lighting system, community radio and television sets, solar photovoltaic panels for spacecraft and weather monitoring, railway signaling equipment, and battery charging. These are the solar water pumps for irrigation and drinking water supply. There is a solar water pump in our NITT for that is a practical training. We are also having a 250. There is a total 500 watts panel. It is a movable one. We have to move to every place, and we have to design a pump that is underwater. That is a 100-liter water tank, and also 50-liter that is overhead tank, and that is a solar pump controller. So that is during the experiment, there how much amount of that is solar energy directly it will be also given to that. That is a solar pump controller and pump. We are also having a 0.5 that is a submergible DC pump. We are also having there's a solar water pump in our that is NITT laboratory. Just some visuals related to that one. It is a solar water pump. It is in our MNRE website. They are also having.
कल का बहता पानी देख रहे हैं जो मेरे खेतों में जा रहा है, ये किसी नहर, किसी डीजल या पेट्रोल वाले पंप से नहीं आ रहा, ये आ रहा है सोलर पंप सेट के कारण।
सौर ऊर्जा के इस्तेमाल का शानदार स्वरूप, सोलर पंप सेट, न बिजली की जरूरत न पानी की किल्लत।
इसे लगवाने के लिए भारत सरकार अनुदान भी देती है।
पर्यावरण का दोस्त, किसानों का हमदर्द, सोलर पंप सेट।
नवीन और नवीकरणीय ऊर्जा मंत्रालय भारत सरकार की आर्थिक सहायता का लाभ उठाएं।
In our laboratory, 1 minute, sir. Solar water pump. It's not available, no problem. We have to end that presentation. It is some of the visuals related to that on how we are getting as a electrical energy used for pumping. And that is, we are also having a solar street lighting system. That is, during that daytime, we are also getting as a solar, that is a power producing in the panel, stored in the battery. Nighttime, we are also using for the lighting purpose. Nowadays, it is a integrated battery systems are coming and used for water. That is a street lighting system. In our NHDR, we are also have a 100 kilowatt. There is a rooftop solar power plant. We are also having power supply for house. That is a standalone. It is a standalone system as well as for the grid connector. It's a power supply system that is whatever the energy we are getting, it will be used for our own purpose, and also for use for solar UPS and solar energy used for the department classrooms. They are also used for, that is a lighting, fan, as well as for projector and also for computers. And rooftop solar power plants, that is efficient utilization of power. It is a nowadays a grid connected solar photovoltaic system. That is a rooftop. In our institute, we are having a 100 kilowatt. That is there also PV panel. It will be using the integrated. It will be converted into AC and distributed board, and it will be used for internal application as well as for using the bidirectional meter. Suppose in this Saturday, Sunday we are not using, it will be exported to the grid. At the final, the tariff calculation, it will be subtracted. There is a grid connector that is photovoltaic system. This is some visuals related to that one. Grid connector solar PV system.
Hi, in this video, we shall explain what the solar grid connected system is and how it works. A grid-connected solar system generally has
Only for
four
a
basic
few minutes
components.
because continuous
solar
lecture is
photovoltaic
not
panels,
suitable for
the loads
the
like
participants.
PV and AC, the solar inverter, and the grid for the main power supply. In a typical building, before connecting solar, the grid is the only source of power and all the loads in the building are run by it. After connecting solar PV system on the rooftop, the power required by the load is supplied by the solar or the grid or both together. The working of an on-grid system can be explained in 5 simple scenarios. When solar generation is equal to the load requirement, the loads are completely run by the solar power. The grid is available, but power from it is not required at this time. When solar generation is greater than the load, the generated solar power will support the existing loads first, and the excess will be sent out to the grid. This is called as export to the grid. When load requirement is greater than the solar generation, all solar power will be self-consumed by the loads. Meanwhile, the grid will join to support the excess load demand. Typically, during night time, when there is no solar generation, the grid will supply power to meet the load requirements. This is called import from the grid. In the absence of the grid, that is during a power cut, the solar inverter shuts down. This is for the safety of the staff working on the grid for maintenance.
Return back to our presentation. So Next one, there is a canal top solar power plants and floating solar power plants. Nowadays, the concept, why that they have to go for the floating solar power plant and canal top. Suppose normally that major concept, due to the continuous solar radiation, the solar PV panel, it will be heated. There is a more heat will be generated. We have to reduce the heat. Only the air cooling, water cooling, nowadays a PCM cooling. So that is a water cooling. Normally the water bodies. First one, the suppose proper, there is a large amount of land is not available at the time used. Second one, we have to cool, that is a we have to make in the cool condition of the PV panel. There is a more amount of production efficiency is the more one. Another one that is in this water body, the evaporation loss of water may be minimized one. And that is a concept used in the canal top solar power plant and floating solar power plant. There is a 1 megawatt plant in Gujarat, that is a canal top solar power plant. 24 megawatt plant at Thuthukudi in Day1, that is a Tamil Nadu. And there is also related to floating solar power plant in Tamil Nadu. 1 minute, so. Is not available here. Okay, no problem. And another also used in the small boats for the amenities and solar powered vehicle, the solar car and the solar boat and solar aircrafts. And also for that is solar aircraft, there is a in the wings there also solar PV panel. Mainly the concept is used that is a solar, there is a energy. It will be used for the electrical power supply. That is mainly used for electrical car. It is run by the solar car and the solar photovoltaic panels on the spacecraft. And nowadays, another one is so nano solar cells. That is a dye-sensitized nano solar cell. The nano coating on the solar cell, which will absorb the 60% more UV, ultraviolet ray and infrared rays than that of the silicon cell. Due to the multiple reflection, the effective optical path for absorption is much larger than the conventional solar cells. So due to that is a light generated electrons and holes need to travel over a much shorter path, and thus the recombination losses are greatly reduced one. Then there is a dye-sensitized, there is a nano solar cell, and that is a efficiency enhancement in dye-sensitized solar cell using the metal nanoparticles. That is a Deba K et al. That is in 2012. There is a researchers, they also did this one. Nowadays, a lot of researchers, they have to use dye-sensitized. Now that is other solar thin film solar cell and silicon solar cell. They are also doing the research. And another one, the solar PV panel cooling using that the form stable, that is a polyethylene glycol 1000 and expanded graphite PCM. That is my work. That is a in this one, that is a major concept I already told. That is a cooling of that is a solar panel. It is used to increase the efficiency. One way, that is a air cooling. Another way, there is a water cooling. Another one, there is a PCM. That is, I also did this work used based on the PCM. There is a polyethylene glycol. And also for expanded graphite, we have to make as a form that is a honeycomb structure, and it will be filled in between that heat sink, and that is a excess energy to be stored. But in this level, we are also used, and that is a efficiency of the solar PV panel is increased one. But there is a further study, that is how we have to use solar energy stored in the PCM. Suppose we have to use for further applications, heat storage. Otherwise, some water may be passing through that, and the water also absorb the heat, and the heat will be used for some other applications. It is research I did in the 2020. That is experimental study on thermal management and performance improvement of solar PV panel cooling using form stable phase change material. That is in the Journal of Energy Sources Part A, Recovery, Utilization and Environmental Effect. There is a solar PV panel cooling using that. That is using form stable polyethylene glycol. There is a PCM, phase change material. There is an expanded graphite combination. That is another reference is solar PV cooling by nanofleets. Some of the researchers, Chandrasekhar M and Sendil Kumar, they did the experimental demonstration of enhanced solar energy utilization. In flat, there is a PV nodules pulled by the heat spreaders in conjunction with the cotton wick structures. And Abdullah SR et al. In the year of there is a 2018 experimental investigation on the effect of using nanofleet and the performance of PVT. There is a photovoltaic and thermal system. thermal science and engineering progress. Ali H et al. That is, they also did in 2018 application of nanofluids for thermal management of photovoltaic models. That is, these are the solar PV cooling in nanofluid. Another one is the solar distillation concept. That is, it is also used to, that is a cure, that is a convert the impure water to, that is a pure water. But using the nano, that is a solar distillation, the nanofluids, they are also using the nanofluids. There is a different type of thermal conductivity and cost of certain nanopowders. The cost is somewhat, well, there is a 3 or 4 years back at the time of my research, it is collected. This is somewhat increased one. Some of the nanopowders, aluminum oxide and zinc oxide, tin oxide, and iron oxide, thermal conductivity watt per meter degree Kelvin. That is a 4029. It is a thing, thermal conductivity, and that is some of the nanopowders. And thermal conductivity, this is the one. There is a reference I have taken from Ilongo T et al. In the performance study on single basin, single slope solar cell with the different water nanofluids. The researcher team, they also did. And solar cookers, box type solar cooker and parabolic top, that is a thing. In the box type, but it is a very slow process. That is, but nowadays some researchers, they also did some coated. That is a box type solar cooker. That is a nano coated. That is a nano material coated. That is it will also, box type solar cooker is produced high energy developing in method to more absorb solar radiation, save energy through a bar plate, and inside use a black pine with sun-dry nanoparticles, aluminum oxide, coating in bar plate area. The cooker is working. There is a, but it is a very slow process. That is in the 2019, Palani Kumar ji et al. They also did this research, energy and environmental control to box type solar cooker and nanoparticles mixed bar plate, coating with effect of thermal image cooking part. And this is the experimental setup for that one. And concentrating collectors mainly used for that is a steam generation, and greenhouses convert the solar light to heat enabling. That is a normal the concept. They are having a transparent material. There is a increased more amount of carbon dioxide, and there is arrest the UV radiation. There is a carbon dioxide is needed for more amount of, that is a photosynthesis process. That is a growing is more for the concept of in greenhouse. That is a increasing, that is a greenhouse cladding by the additive of inorganic nanomaterial. They used the purpose is improve the plastic greenhouse cladding to reduce the transmittance of IR and also the low density polyethylene. That these are the researchers Lucy et al. In the 2018 improving the greenhouse cladding with the nanoparticles. These are some research that is some of the examples I have given from that. That is from the various research. So these are the researches going on. Further studies. There is, I am also giving an overall view of all the solar energy gadgets from the starting from the solar thermal to advanced level of solar PV system. The further reference you have to refer the Ministry of New and Renewable Energy Sources, and also for National Institute of Solar Energy, Solar Energy Corporation, Central Electrification Authority, Power Mean, and YouTube. Some of that visuals I have also shared from the YouTube. So directly you have to see that one. So in this session, we also discussed that, but my approach is somewhat different because more than 22 years I was in the training system. So I'm also in the way of the training with me. I'm also, that is delivering my lectures and other things. So that is advancements and solar system. That is a basic concept of energy, conventional stages, law of energy conservation, energy science and energy technology, energy engineers. I'm also giving the task to the energy engineers. I think a lot of engineers, they are also watching. That is sir, I am also publishing the paper and completing the PhD and also appointed in some company and getting salary, settle the life is not the goal of the energy engineers. Energy engineers, you have to design, develop the equipment, design. There is a device, gadgets. It will also capture that energy resource and useful for the society. That is a duty of energy engineers. I am also giving my words to you. After 5 or 10 years, I have to meet the participants here. Sir, due to your words, I also invented this one. I am not publishing that. Lot of publishing papers is not a good one. Lot of people, they are also changing the parameters. Publishing is not a good one. You have to invent a device. That is an important one. Application part of energy science and work and process, energy man environment, and different uses of renewable energy sources, world electricity production, Indian energy scenario, and Indian renewable energy as on the date solar power cumulative, and and science of solar energy. And sun is the mother of, and some data related to solar energy, solar radiations, measurement of solar radiation data, application, water heating, and also for thermal training, focusing type, and also solar water heating using the nanofluids, solar space heating, and also for nanoparticles and fluids used for space heating, and vapor compression system, how the solar energy is used, vapor absorption system, how they are using solar energy, and there is a solar PV cells, and what are the research is going on with the help of the nanoparticles, and also for license wise, there is a grid connected solar power plant. These are the major things now we have seen. Now I have to stop this session now. Okay, sir. Hello, sir. Is it audible? Sir, I stopped the presentation.
Yes,
Any
sir. It's
discussion?
audible, sir. Any questions from the audience side? If you have any queries, please raise your hand.
Okay, sir.
Dr. Naresh, sir, please continue.
The participants, there is
So, sir,
yes, sir. Yes, sir.
Am I audible, sir?
Yes, audible.
Yes, it was very much informative, and we felt very much learning happened this session. Thank you for that, sir.
Yes, sir.
Actually, I learned a lot about that solar PV training system which you explained in the laboratory.
Yes, sir. Yes, sir.
So we used to have in our laboratory when we were doing PhD, but we did not have that much awareness about that system. But today I learned a lot. Thank you for that. Sir, actually, just now I seen almost at the closer of the presentation, you presented about that solar PV with PCM
Yes, sir.
integration. So can you little bit elaborate that and how we what is the
that is there is a polyethylene glycol and also for expanded graphite. We are also normally that is a, but it is a general ATAL program. I am also discussing in that way, training way. It is maybe the conference means we have to discuss that. Otherwise, I am also telling that is a thing. I did the work. Normally, that first concept we have to reduce the temperature of the PV panel. It will also increase efficiency. One concept. Normally, they are also using that, and a lot of floating solar power plants. They are also using for that is a temperature. That is a temperature reduction. That is a phase change material we are using means polyethylene glycol and expanded graphite. Why we are using means normally that there is a backside of the PV panel. We are also fixing the heat sink. That is a heat sink. Normally, the people also using the PCM due to that that is a heating. Automatically, that is due to the liquid position, due to the gravity, it will come downward direction.
Yes.
So there is no contact between the PV panel and also the PCM. So we have to mix the expanded graphite and mixing with polyethylene glycol to make us a honeycomb structure. In the honeycomb structure, so on the time, suppose anything that is it may be heated means due to that honeycomb structure, it will not come downward direction. That is due to that heat. That is a wax material. That is a polyethylene glycol, like as a wax material. Will go and fill that is a pores of that that is honeycomb structure. So there is a continuous that is a contact between the PV panel and also the PCM is possible. That is in this way we are also using, sir.
So this honeycomb structure is made up of some metal, sir?
That is a expanded graphite. Expanded graphite and polyethylene glycol. We have to mix both the things.
Okay. So that is ensuring the honeycomb structure, you are saying.
Honeycomb
by mixing that.
Mixing that.
Okay, what is the proportions we can mix? Any suggestions on that? How much proportions is
normally that is we also did for that is a 5% and 10% and 15%. We also did some optimization. That is a 10% is suitable for our research, sir. We used for 10% is suitable, and we also used for a 10% of that is a EG is mixed, expanded graphite is mixed with the polyethylene glycol. We also made.
What is the reason you selected only PEG, and what is the transition temperature
that is
of that?
Polyethylene glycol. That is the thing, sir. Normally, our temperature in our suppose in Tamil Nadu condition, that is a PV panel that is a 30 to 35 degree. It is normal wax material. It will be melted at 55 to 60 degree only melting. Normal wax material we are not using, but normal 30 to 35 degree temperature, it will be melted, sir. That is a melting point of the polyethylene glycol.
Okay, okay.
So we have to choose this that is this PCM is used for our research because normal
PEG, which numbers are PEG 600 something will be there, no?
1000 PEG 1000 PEG
1000. So that is having 30 to 35 melting points.
Yes, sir. PEG 1000. I'm also sharing that one, but my detail is available in the paper. 1 minute, so I am also sharing.
I will go through that paper also.
Yes. I think myself and Ravi also involved. This organizer also involved in that research.
Nice.
Yes, sir.
This one.
Sir,
I have to note that.
Sir, can I approach you for any further doubts or queries about future research?
Yes, no problem, sir. It is I am available in NIT Vidya.
Okay.
1 minute, sir. 1 minute. I am also showing that one, but I think. I am sharing that one. It is also very much useful for you. This is we are compared with bare PV panel, heatsink panel, heatsink plus PCM PV panel. So 3 panels.
Yeah, actually, I can't see the screen, sir. I think some text document is visible here.
Sorry, okay. 1 minute. I have to share again. 1 minute. 1 minute. Sir. I share. 1 minute. Share the entire screen. Share. Now it is visible, sir?
Yeah, now it is visible. Can you make it
this one, sir.
Yeah.
So that is in the year 2020, it is in the online publication. Now in 2023, published in that is journal with the numbers and other things, sir.
Nice, sir. Nice. So here 3 panels are there. Can you explain that?
3
What
panels.
is that?
Compared, we have solar PV panel, bare PV panel. So heat sink is PV panel for air cooling purpose, and heat sink PCM. That is our farm stable. In the topic, it is missing the solar PV panel cooling using.
So one is without PCM, one is bare panel. What is
another one is air cooled? That is air cooled heat sink.
Okay, just air cooled. That is.
Air cooled using the heat sink.
So you mentioned farm stable PCM. Can I? What is that farm stable?
Farm stable means that is honeycomb structure because due to that melting, it will not deform, sir.
Okay, so there is no leakage observed, sir.
There is no leakage. We are also covered for that. Our experiment purpose, we are also using the glasses and other thing. In further study, it is possible. We have to take the heat for further. That is the further applications. In this study,
below the panel, we kept some box kind of thing or what?
There is a heat sink. In the gap of the heat sink, we filled that farm stable material.
Okay, there is no leakage. Leakage is arrested because of this box kind of thing.
That is for experimental purpose. We are also arrested with the transparent materials, sir. Suppose it may be used for large scale means we are also using. We have to take on. Suppose we are sending also water pipes. We have to take that heat for utilization. Yes, sir.
Okay. Sir, here you mentioned how much thickness is maintained, sir, from panel bottom layer to this. Box you mentioned.
Total study, that is suppose we are also using the total heat sink, sir. Heat sink that is a design and other thing, it is available in the total in that paper, sir.
Okay, then I will go through
paper. That is elaborately I have given from the literature review which type of heat sink dimensions are the thing, because it is a normal training, but I am not taken these things.
Suppose, sure, sir. I will go through that paper.
You have to note down these names. There is
yes, sir.
Study
I noted down, sir.
The dimension of heat sink, how we have to mixing that one, different type of study. That is XRD, and also for electron microscope study. How do we change? Lot of study available in that one, sir.
Sure, sir. I will go through that.
Difference. The people are that is I am taking in this training way means I also in this training system more than 22 years. Okay, sir. There's a training system. Normally, we have to give. That is this adult concept was developed by our former director, NIT former director Punya. After he joined in AICT, he developed this adult concept. That is adult training program. How we have to teach and research and other thing. But that is a conference only. We have to discuss the research and other things, sir. There is a difference between the training and research. That is a conference. So I am also discussing in the way of training. But that is some of the information that is available in this one, sir. That is elaborately. Yes, sir. Yes, sir.
Sure, sir.
So
I will
in
go through, sir.
conference
Thank you,
means
sir.
I will also explain in the detail manner.
Sure, sir. I will approach you, sir, personally.
Yes, sir. Yes, sir. Your good name, sir? Naresh.
Myself is Dr. R. Naresh, sir. I am from
Naresh. You are
BRT
working in
Narsapur.
which place?
Yeah,
Which
Assistant Professor, Mechanical Department, BRT Narsapur, Telangana. Hyderabad.
Telangana. I think in our NIT, a lot of people from Andhra Pradesh, but most of the polytechnic teachers, there's a Directorate of Technical Education. They are also deputing. They
Okay,
are
okay.
also deputing the participants for the training.
Okay, okay.
Okay, sir. But the engineering college teachers also you come for our training. And
Okay, sir.
of technical
Definitely,
teachers.
I will look forward, sir. I look forward to attend some kind of training.
Okay, okay, sir.
Thank you, sir. Thank you.
I think the organizer, that is Kotala Ravi Kumar, is also one of the researcher in the team.
Yes, sir.
Yeah,
Yes,
sure,
sir.
sure, sir. I will also approach him.
He also available near to you. That is Vijayanagaram.
Okay, sir.
Yes, sir. Yes, sir. Sure, sir. Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Okay.
Yes, sir.
Any other?
Dr. Anil Prakash, sir.
Yes, sir.
If you have
Please.
any queries, so you please ask it, sir.
Sir, please, sir.
Yes, sir. Yes, sir. Please, sir.
Good evening, sir.
Yes, sir.
I have a question on flexible solar panels, sir. What is the role today and how it is increasing the efficiency?
But we are also concentrated in solar PV panels. And normally the flexible solar, there's a thin film solar cells they are also using. But my research area is only for the solar PV panels. Thin film, but we did not try it in that research area. Sir. I think some people are doing that one, but the power capacity production is lesser compared to our fixed rigid solar panel. Hello. Hello, sir.
Sir.
Okay.
I think thin film, that is a separate research. That is now the research is going mainly for our solar PV panels. That is silicon based.
Yes.
Yes, sir.
Okay, sir. From my side, I would like to sincerely thank you for accepting our invitation and sharing your valuable insights with us. The session was incredibly informative, sir. You provided an excellent overview of energy scenario in India, which is essential for understanding both the country's energy demand and need for the increased renewable energy installation. Additionally, you have discussed on that applications of solar energy was highly enlightening. We are also appreciated the quick review of various solar assisted energy systems and the experimental setups available in the NITTR, which are you kindly shared with us. So thank you so much, sir, for your valuable insights. So I request if you in future if any sessions organized by Ambassador College of Engineering Mechanical Department, you have to come to that come to and take some sessions, sir. Thank you so much, sir.
Once again, I thanks to Dr. Subramaniam sir and Ravi Kumar and also other organizers given the opportunity to discuss these things with people, the participants. Once again, thank you. Thanks.
Okay, thank you.
Thank you so much.
Thank you so much, sir.
Can we leave?
Yes, sir. You can leave.
Okay.
Okay. So, dear participants, I hope you are enjoying with these two sessions. Tomorrow we have two more sessions. I will share that links into the WhatsApp group as well and mail also. And no need to give that feedback for individual session. And altogether we have to give the feedback in the ATAL portal. So that is sufficient. But earlier we thought like everyday feedback session we want to take, but we are not considering that part. And overall feedback you have to give into the ATAL portal, sir. Any questions? And I will share that materials in the group as well also. So and one more thing, my request is so in the group we have actually 230 people are registered as of now, but in online it is showing only 150 participants are appeared. You are aware about that attendance is mandatory, so we're not manipulating any attendance. So uh, kindly attend that all the sessions and generate your e-certificate in the ATAL portal, sir. Thank you, sir. This is my kind request from my side.
Thank you, Ravikumar. And also thank you all for your active participation and enthusiasm today. It truly made the session more impactful. And we look forward to seeing you in the upcoming sessions. Thank you so much. Ravikumar Garu?
Yes, sir.
We will close this today.
Yes, sir. We can close the session.
Thank you all.